let us see the question. Let us see the question 91. The same question given in the 2021. In this one, what is star connection is given, is asking the equivalent delta, is asking the equivalent delta. Now what is the one of the requirement is the RAB. RAB. Now what is our formula is the sum of the possible products, sum of the possible products by the opposite resistor. Sum of the possible products by opposite resistor. Now correspond this RAB, correspond to RAB, what is the opposite resistor is a 40, opposite resistor is a 40. Simplify it, by simplifying this one we get this RAB, RAB is a 35 ohms, RAB is 35 ohms. Now can you see the options, which options are eliminated? Now C option is eliminated, D option also eliminated. Now come to this A and B options. In the A and B options, now let us find out the RBC. RBC. Now what is the opposite resistance for this one? For this RBC, opposite resistance is a 10. The numerator, if you add all these values, 1400. By simplifying this one, 140 ohms. Now can you eliminate the B option also? Now what is the correct option is? A is the correct option. Now in this example, what is the requirement is the number of possible trees, number of possible trees for a given graph. What is the standard formula for this one is a in the given figure, total how many nodes are there? The number of nodes are the 4. In the question, total how many nodes are given here? 4 nodes are given. By simplifying this one, total how many possible trees here? 16. Number of possible trees are the 16. Now I want answers from your side. Can you give the answers for this question number 93? I want response from your side. I want response from your side. Okay. In this question number 93, what is asking the fundamental cut set, fundamental cut set. To conclude the answer easy way, let us take the any tree. Suppose if I take this with the 2 and 4, 2 and 4 as a tree. What is the tree definition? Tree is a connected subgraph. In this example, I have taken the 2, 4 as a subgraph. It connected all the nodes 1, 2, 3. It is connected all the nodes. No closure paths are present. In the question, Kabuchraji is asking the fundamental cut set. Fundamental cut set means it consists of only one tree branch. It consists of only one tree branch. Now corresponds example here. The combination of the combination 1, 2, 3. The combination 1, 2, 3 we can call as a basic cut set. If you observe here, if you observe the options here, one of the options is satisfying is a B is a satisfying, B is satisfying as well as. मगर एक क्वेश्चन में ध्यान से देखें तो one more option also satisfying, one more option also satisfying. Now suppose if I take the now suppose if I take this as one more possible tree, देखो जी in this example tree branches are 1 and 3, 1 and 3. Now what is our requirement is a basic cut set. What is the requirement basic cut set? Basic cut set means it should consist of only one tree branch. It should consist of only one tree branch. देखो जी, always the cutting should be started from the outside of the graph, outside of the graph. After cutting all these branches, the finishing point is also outside. In the set of branches also, how many tree branches are there? Only one tree branch. That means what is the one more answer is a 1 to 4. That means here for this particular question, two options are there. A is the correct option and B is also correct option according to given question. Now it is a directly memory based questions, directly memory based question. Now what is the statement given as a this R by 2L less than 1 by root LC. It is the correspond which system? Under damping. It is the correspond which one here? Under damping system. For this under damping system, total how many roots are possible here generally? Now generally we go for the 4 cases: over damping, critical damping, under damping and undamping. Now in case of the under damping, whichever roots are possible? Complex conjugate, complex conjugate. C is the correct option. Now in this question number 25, in the question itself they mentioned RLC series circuit. देखिए इधर R value given, L value given, C value is given. What is our requirement is the type of the response. देखो जी इधर आंसर आसानी से कंक्लूड करने के लिए simply can find damping ratio of this circuit. For this RLC series circuit, for RLC series circuit, for damping ratio formula is R by 2 root of C by L. देखो जी क्वेश्चन में दे दिया रेजिस्टेंस वैल्यू कितना इधर 4, resistance value 4, but capacitance value 1, capacitance value 2, inductance value also 2, but the damping ratio equal to 2. That means in this analysis we got the damping ratio greater than 1, we got the damping ratio greater than 1. That means which system? Over damping. Which system is the over damping system.
Question number 96 is belongs to the transient analysis. So don't do the total problem is here. So V output of S. So first you have to convert this current source to voltage source, and you have to convert to a Laplace transform. Laplace transform is 10 by S. This value is 10 by S. This value is 1 by Cs, that is a 4 by S. So this current into impedance is a voltage. So 10 by S into 4 by S. This value is 40 by S square. Now connect the capacitor in series, inductor and resistance. This circuit. Now 1 by Cs, 4 by S. This value is S and 4 ohms. Our requirement is voltage across 4 ohms. Use voltage division rule. V naught of S is equal to 40 by S square into 4 upon S is 4 plus S plus and 4 by S. If you do the numerator, suppose 40 into 4 by S, S is get cancelled here, is going to the numerator, S is get cancelled, S square plus 4S plus 4 into S. So our intention is only S square plus 4S plus 4 and S. So this is, it can be written as 40 into 4 by S into S plus 2 whole square. If you are using a partial fractions, that is A by S plus B by S plus 2 and C by S plus 2 whole square. Whenever the roots are repeated, always it is the nature is critically damped, and you see these options. Here A option में देख सकते हैं आप, here is, here the roots are, here is a 1, another is a -2 and -2. These are the poles of this system. S is equal to 0, this is a now -2 are the poles of this one. So here is, which one is will give the -2 and -2? In this option, here is a -1 and -1. It is not a correct. -2 and -2 is there. This is the correct option. Directly you can say B is the correct option. In this option, -1 and -2. In this option, -2 and -1 is there. The roots are repeated. The roots are repeated means the poles are repeated, -2, -2. Directly you can say B is the correct option for this. So don't do the total calculation. Based on the RLC values, you can say directly the option is B. Okay, this 96 option is B. And 97, for the network shown in the figure, in this RC network, this is first order circuit, you are asking about the V of T. So T is equal to 0 minus, T is equal to 0 minus, where is the position of switch? The switch position is at A. So 6 volts, T is equal to 0 minus, the capacitor is reached to a steady state, 6 volts, here is the resistance, and capacitor is reached steady state means open circuited, and it is 2 ohms. So volt across capacitor, initial value Vc 0 minus is, so based on the voltage division rule, Vc 0 minus is equal to 6 into 2 by 2 plus 4, 6. This value is 2 volts. So after T greater than 0, the switch is connected to the B. Now the circuit becomes 2, 4 and capacitor, and I'll say 2 ohms. Here also don't do the total problem here. Don't solve this total problem. You have to find out just time constant. इसमें आप देख सकते हैं time constant is T by tau. Here 2 by 3 is there, 2 by 3 and 2 by 3 1 by 3. सो 2/3 में पक्का ए बी सी में एक ऑप्शन रहते हैं. एंड सेकंड इज 2 volts is the initial voltage. This is a source free circuit, so 2 into e power minus t by tau. So directly you can say A is the option. Otherwise you can find out the R value. R equivalent is how much you are looking from the capacitance. R equivalent is equal to 2 4 are in series, that is 6 into 2 by 6 plus 2, 12 by 8, 4 3 is the 4 2 is the 3 by 2. Tau is equal to 3 by 2 into C is how much the value is, C is 1. So here is 3 by 2 is the tau. So 3 by 2 is the time constant here, time constant 3 by 2, 3 by 2. But here initial voltage is 2. So option A is the correct for this question. A is the correct option. Next is move to the 99 question. Direct this is asking about transfer function V2 of S by V1 of S. Directly use a voltage division rule for this. So 1 by Cs upon R plus 1 by Cs, it becomes 1 by RCS plus 1. So which option is correct? Option A is 1 by 1 plus RCS. B option is correct for this question. 99. Question number 100 is given is Z parameters. You are asking about H parameters. First write down the Z parameters now here. V1 is equal to, direct write V1 is equal to Z11 is 2I1 and Z12 is equal to I2, equation number 1, and V2 is equal to Z21 I1. What is Z21 is given is 10 I1 plus, and Z22 is 11 I2. This is based on the given information Z parameters. Now asking about H parameters. You write now H parameters. V1 is equal to, equation is H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Now compare both equations. V1 V1. Here I1 is there. I2 in place of V2 there is I2 is there. So write the equation from here. I2 is equal to, you are going to this side, minus 10 by 11 I1 plus 1 by 11 I2 V2. This is equation 3. I2 in terms of I1 V2 आप directly compare कर सकते हैं, get H21 and H22. Now substitute this in one equation. You would eliminate I2 here. So V1 is equal to 2I1. Here directly elimination is not possible here. Why? Because H21 is minus 10 by 11. Here minus 10 by 11 is there. Minus 10 by 11, minus 10 by 11. And also A also there. And 1 by 11. But 1 by 11 here A option is there and D option. A D में बीच में रहते. So B and C आप remove कर सकते. C में भी है minus 10 by 11. Here D also there 1 by 11. So 1 by 11 is C. आप देख सकते हो here is. So minus 10 by 11, minus 10 by 11, minus 10 by, ये देख रहे हो 1 by 11, A 1 by 11 है, ये ऑप्शन हो सकता है. So 1 by 11 A नहीं है, B रिमूव कर सकते and 1 by 11 ये है, D रिमूव कर सकते. Only the A C में होने की चांस है. So अभी you would find out the H1 and H12 then get answer now. Here you substitute here now V1 is equal to I1 plus I2. What I2 is minus 10 by 11 I1 plus 1 by 11 V2. 11 2s are 22 minus 10. That is a 12 by 11 I1 plus 1 by 11 V2. So which one is the now option is correct? A option is correct. 12 by 11, 12 by 11 is same, but 1 by 11 is a H12. Here 10 by 11 is there. So option A is a correct for this question. So C is not a correct one. So both are 10, 12 by 11, 12 by 11. Here 1 by 11 के place में 10 by 11 है, इसलिए A option is a correct for this question. Next is given ZA, ZB values are not given. Lattice network में A represent करना है. So the pi network is given. You have to find out the Z parameters for this one. So what is the lattice network? So standard lattice network is here is ZA, here also ZA, symmetrical lattice network. I think you are studied in a two-port network. Here ZB and here also ZB. For this network, what Z parameters are? Z11 is equal to Z22 is equal to ZB plus ZA by 2, and Z12 is equal, Z21 is equal to ZB minus ZA by 2. ZB must be greater than ZA. So from this phi network you would find out the T network. Otherwise Y parameters find out करो, इसमें से आप Z parameters भी find out कर सकते हैं. Z is equal to Y inverse, you get a Z is equal to, you get a 6446. Otherwise you have to use directly transformation Y to Z. So which one will be the 6? ZB plus ZA by 2, 10 plus 2 by 2. So ZA plus ZB by 2, 10 plus 2 by 2 is give the 6. But first second option में आप देख सकते हैं, here ZB minus ZA होना चाहिए. ZB minus ZA, you are getting a negative value, that's why A option is the correct. 10 minus 2 by 2. So ZB 12 is equal to Z21 is equal to ZB minus ZA by 2, that is the 4 ohms. So option here A is a correct, B is not a correct answer. Here directly तो नहीं है, 4 plus 8 by 2, okay, but ZA minus ZB by 2 is not a correct, and this C option is not a correct and D option is not a correct, only A option is correct. So confusion रहते हैं ZB ZA में, but ZB is must be greater than ZA होना चाहिए. This is a standard model for the symmetrical lattice network. Next, what is the Thevenin equivalent impedance of the circuit shown in the figure? So directly you can looking from here now, ZTH you have to replace with a short circuit. So these two are looking from here, these two are in parallel, and after parallel you getting a this is the impedance and this is resistance. Here ZTH is, these two are in series. So the value is ZTH is equal to 6 plus J2 into minus J4 upon 6 plus J2 minus J4 and in series with the 10 ohms plus 10. After calculations, so you get a ZTH value is 12.4 minus J3.2 ohms. So option A is a correct for this question. Okay, ZTH directly. 106. A is belongs to the mutual magnetically coupled circuits. So the self inductance of 3 coils are LA. So 106 here the question is the self inductance 3 inductance are given LA, LB, LC, and the mutual fluxes of between A and B are is addition. Addition means both are dots are same position. A and C is opposition. Once A and C are opposition, B and C also a opposition. and MAB is 8 Henries between these two. AB, this is A, this is B, and this is C. And MBC, BC between B and C is this opposition, directly you can say 12 Henries, and A and C is 10 Henries. Here is a 10 Henries. If you write MAB is positive, here 8, MBC is negative minus 12, and MCA is also a negative, the minus 10. So if you write L equivalent for this directly, you can say first you add all 20 plus 30 plus 40. That formula is there now for 2 LA plus LB plus is 2 times here, plus 2 into MAB, 2 into 8, and minus 2 into BC, that is BC is 12, and minus 2 into AC. AC is how much? 10. So you do the calculation, you get a 62 Henry is the answer for this question. LA plus LB plus LC plus 2 MAB minus 2 MBC minus 2 MCA, directly formula भी कर सकते, otherwise you would write a KVL equation for this one. Okay. So this is a basic fundamental question. A coil consists of 1000 turns, N is given 1000. The question number 130. Copper cross sectional area is given, A is equal to 0. mm square में दिए थे, you would convert a meters, that is a m square minus 6. And the length is, mean length is given for the only per turn. A याद में रखना, here per turn दिए, total 1000 turns are there, per turn दिए, here 80 centimeters, 80 into 10 to the power of minus 2 meters. Next is resistivity is given, rho is 0.02 into 10 to the power of minus 6 ohm meter. Here 1000, N is equal to, sorry, N is equal to 1000 is given. And power, and asking about resistance, R is equal to what the value, and next is 100 volts DC is connected to the resistance, what is the power, P is equal to how much. So what the formula, directly R is equal to rho L by A for 1 ton. Here 1000 ton के लिए you have to multiply with N into rho L by A. R is equal to, rho value is directly given 0.02 into 10 to the power of minus 6 into L value is given 80 into 10 to the power of minus 2. A value is 0.8 into 10 to the power of minus 6 and also multiply with 1000. This value will give the R is equal to 20 ohms. Once you get R is equal to 20 ohms, power is very simple, P is equal to V square by R for a D supply. Here V square by R, 100 into 100 volts by 20. 20 ones are 25, that is a 500 watts. So option में है, here directly 20 ohms option में है, 250 watts नहीं है. So directly C is the option is correct for this question. Okay.
In this example, what is our requirement is a potential difference. What is the requirement? The potential difference between the A and the B. If you observe carefully here, for this particular example, loop 1 and loop 2. For this particular example, if you observe carefully, loop 1 and loop 2 both will operate independently. Reason is here the connection is not present, written path is not exist. That means first we can conclude as a current of this branch. First we can use statement as a current of this branch is equal to 0. The current of this branch equal to 0. Then what is our requirement? Potential difference A and B. Now let us find out the current of each loop. Now let us give the name for the current of this one as a I1. देखो जी वोल्टेज कितना है 30, रेजिस्टेंस कितना है 5, 10, 15, सब जोड़ दिया तो 15 and 15, टोटल रेजिस्टेंस कितना होता है 30. voltage 30 हो गया, पूरा resistance जोड़ दिया तो the total resistance also 30, but current of this one is a 1 ampere. Now 1 ampere current is coming here, wherever the current is entering that is positive, other one is a negative. देखो जी current 1 ampere, resistance कितना है 15, but the voltage will be ना 15 volts, voltage is 15 volts. Come to this one. Here we देखिए, now 6, 4 and 10, 6, 4 and 10, how the all these three elements are connected in the series, but total resistance is 20, total resistance 20, voltage also कितना है इधर 20, that means let us give the name for this one as I2, I2 equal to, we can write as 20 by 20, again what the current of this one is a 1 ampere, the current of this one is a 1 ampere. Now I2 current is coming like this, wherever the current is entering there is positive and other one is a negative, other one is a negative. Now current 1 ampere, what the resistance is the 10, what the voltage will be the 10 volts. देखो जी क्वेश्चन में क्या पूछ रहे हैं आपको, इज आस्किंग द पोटेंशियल डिफरेंस बिटवीन ए एंड बी, पोटेंशियल डिफरेंस ए एंड बी. देखो जी आप ए एंड बी पॉइंट्स देखे तो वन इज 15 वोल्ट्स, लेट स्टार्ट फ्रॉम 15 वोल्ट्स इज द रेफरेंस, 15 वोल्ट्स. देखिए इधर माइनस प्लस बोल तो एडिशन, माइनस प्लस बोल तो एडिशन. नो करंट जीरो मीन्स फॉर द रेजिस्टेंस नो वोल्टेज ड्रॉप इज प्रेजेंट, नो वोल्टेज ड्रॉप इज प्रेजेंट. अगेन द माइनस प्लस एडिशन. इधर देखिए माइनस माइनस सिमिलर पोलैरिटीज बोलते सब्ट्रैक्शन. नो वी नीड द पोटेंशियल अप टू पॉइंट बी. आप ये सिंप्लीफाई करें तो चेक कर लो, वी ए बी इज इक्वल 30 वोल्ट्स, बट पोटेंशियल डिफरेंस ए एंड बी इक्वल टू 30 वोल्ट्स. Come to this one. In this example, what is our requirement is a VA. He is asking node voltage. For this particular example, what is asking the respect to node voltage? Can write the respect to node equation here. Now take this point as a ground. Take this point as a ground. Then by KCL. Now with respect to ground potential, what is the polarity at this point is a plus. Whenever you are writing the KCL equation, always assumption the node voltage is greater, always node voltage is greater. Now correspond to branch 1 plus subtraction, but corresponding resistance is a 5, outgoing current. Now what about this VA by 2? VA by 2 also outgoing current. Now again the plus subtraction, VA minus 10 by 3 outgoing current. But in this example, what if 10 amperes is the incoming current? Let us sum of outgoing currents. This example, sum of outgoing currents equals sum of incoming currents. Now what is the unknown? This one is the only VA. Now by simplifying this one, can you find VA value? Can you give the answers? बोलिए answers बोलिए. Now what about your answers? Checked out. B is the correct option. Checked out. B is the correct option. Come to the next one. Now again in this example, what is the requirement is we have to find a load resistance such that maximum power is transferred, maximum power transferred from source to load, That means can I select this here? What is the condition for the maximum power is RL equal to R Thevenins. But the condition for this maximum power is RL equal to R Thevenins. To find out the R Thevenins, what is the procedure? First deactivate all the independent sources. जो voltage source है ना, that voltage source is replaced by short circuit. Voltage source is replaced by short circuit. Voltage source replaces the short circuit, and with respect to load terminals, now you have to find out equivalent resistance. Now just give the name as some AB, 10, 30. Now what is our requirement of the equivalent resistance with respect to A and B? That equivalent resistance let us name as the R Thevenins. Then according to connections, if you observe the 10 and 30, one joint is connected here, correspond 10 and 30, one more joint is connected here also. That means here we can give statement that this 10 and 30 both are connected to the panel. Similarly 20 and 40, one joint is connected here. देखो जी, one more joint is connected like this. That means how the 20 and 40 both are connected to the panel. Then if you simplify this one, in this example 10, 30 in the parallel, we can use the formula R1 R2 by R1 plus R2. Similarly 20 and 40. Similarly the 20 and 40 also connected to the parallel. Now by simplifying this one, can you find R Thevenin's value? Anybody give the responses? What about answer for this one? Checked out. B is the correct option. Come to the last one. Last one is a very easy question, directly can conclude. Now which network is given here? Now this, what about the Excel inductive nature? Inductive nature means what is the nature of power fed is a lagging. What nature of power fed is a lagging. In the question itself mentioned RL circuit inductive nature. Now what is the cos theta formula? क्वेश्चन में क्या पूछा जी, पावर फैट जनरल फॉर्मूला क्या है, आर बाई जेड. इंडक्टिव बोलते हो नेचर ऑफ पावर फैट क्या है, इधर लैगिंग. दैट मीन्स व्हाट इज करेक्ट आंसर फॉर दिस इज सी. करेक्ट आंसर फॉर दिस इज सी. I hope you have attempted all the questions. Thank you.
Good evening all. Let us now take up questions from control system part. I am very much confident that you all might have done very well, because around 13 questions are there from control system, and most of them are from the Made Easy workbook and our classroom discussion, except one or two. Almost 10 questions out of this 12 to 13 questions are from Made Easy material. So you might have come across all of them, those who have been Made Easy students, and very simple and easy questions. Taking this question, a second order system has got the closed loop transfer function to be 25 upon s square plus 8s plus 25. Question is to find the settling time for 5% tolerance band, that is to be noted. We usually do settling time for 2% tolerance, which takes to be 4 by zeta omega. So two things needs to be focused first. Is it under damped or over damped or critically damped? Because formulas are different. And then what is the percentage of tolerance? Two things has to be focused. Roots are complex conjugate. Otherwise, omega n of the system is 5. Zeta of the system is 0.8. Zeta less than 1. Under damped system. Under damped system का जो settling time है वो वाले formulas इस्तेमाल करेंगे. So settling time is 3 by zeta omega n for 5% tolerance. For 1% tolerance 5 by zeta omega n. For 2% tolerance 4 by zeta omega n. So this is 3 by 4, option B. In this question, we are given with the step response of standard second order system for unit step input. See, we know that the step response of standard second order system is 1 minus e to the power minus zeta omega nt by root 1 minus zeta square sine omega dt plus phi u of t. This is the step response of standard second order system for unit step input. If it is mentioned to be standard second order, then you can take this 1 by root 1 minus zeta square to be 2 by root 3. Otherwise, you cannot. The most simple way is, this is alpha, alpha is equal to 1. And this is omega d, whether it is cosine or sine, that is omega d. Maybe cosine or maybe sine, sinusoidal. So, omega n is root of alpha square plus omega d square, that becomes 2. And zeta alpha by omega n, that becomes 0.5. So transfer function of the standard second order system is omega n square upon s square plus 2 zeta omega n s plus omega n square. Answer to the question is D, 4 upon s square plus 2s plus 4. Consider a second order system with a transfer function 1 upon s square plus 2s plus 1 with the unit step input as input, with RFS 1 by s as input. Question is to find the time at which the steady state response becomes 94%. at which the response becomes 94% of its steady state value. Whenever we come across a second order system, we should be very careful with the damping behavior first, whether it is under damped or critically damped or over damped. That's the most important thing. This system is critically damped because roots are real and equal, critically damped. Otherwise, we can say that omega n is equals to 1 and zeta of the system is 1, critically damped. The expression for the step response of a critically damped system is 1 minus e to the power minus omega nt multiplied by 1 plus omega nt u of t, where omega n is 1. So, that is 1 minus e power minus t 1 plus t u of t. This is c of t. Its final value is 1. We have to find the time at which this becomes equal to 94% of its final value. By solving this, we get this t to be 4.5 seconds. This is one way, and if it is becoming difficult to solve this one, what can be done? You can substitute hit and trail method. I mean, you can substitute each of this option in this expression. You can substitute one by one, and you will get that. For this one, you will get it to be 94%. Answer to the question is option C. Non-minimum phase system is the one which has got, non-minimum phase system is the one which has got either a 0 or a pole in the right side of S plane. Minimum phase system is the one which has got all the poles and zeros in the left side. If there is anything in the right side, we call it to be non-minimum. Particularly, zeros is what most commonly seen. So, which has got zeros in the right side of S plane. That's simple. Next one, a system has got poles at 0.01, 1 and 80 location and zeros at 5, 100 and 200 location. Question is to find the approximate phase of the system at 20 hertz. So, we have to find approximate phase. Then we can do one thing. Before frequency 20, we have this pole, not this pole, and we have this 0, not this 0, not this 0. So, before this frequency where we have to find the phase, how many poles and zeros are in force? 2 poles and 1 0. So, you can say that phase is P minus Z into minus 90 degree. That is 2 minus 1 into minus 90. Minus 90 degrees, the answer to the question. This question is from the previous paper, is there in the ESE material. The magnitude of the frequency response of an underdamped second order system is 5 at 0 radian per second. I told you the option to the previous question, right? Yeah, option A. Right. So, 0 frequency pe magnitude 5 or 5 root 2 frequency pe 10 by root 3. Plotting this, magnitude 0 frequency pe 5 hoga. This is also from the previous papers. It's a repeated question. And at frequency 5 root 2, the peak is 10 by root 3. Question is to find the transfer function of the system. See, this is not standard second order system because transfer function of the standard second order system is omega n square upon s square plus 2 zeta omega ns plus omega n square if I find the 0 frequency gain. In time domain, we put s is equals to 0. In frequency domain, we put omega is equals to 0. And we get the DC gain or DC magnitude to be 1 in case of standard second order. But in the given system, it is 5. Hence, the transfer function that we need to design is 5 omega n square upon s square plus 2 zeta omega ns plus omega n square. What is given? Resonance frequency is given. Resonance peak is given. Resonance peak is 1 by 2 zeta root 1 minus zeta square. For standard second order system, unit input amplitude. But this is like 5. That 5 should be taken into the calculation. This, most of the people might have done mistake here. This is for standard second order, 1 by 2 zeta root 1 minus zeta square. If it is not standard second order, then that extra multiplier has to be brought into this. We write it to be actually a by 2 zeta root 1 minus zeta square, that a is this figure. And this is given to be 10 by root 3. From this, if you solve zeta, you will get two values. One becomes 0.5, the other becomes 0.86. In frequency domain, underdamped system is the one whose zeta is less than 1 by root 2, that is 0.707. This is underdamped, this is overdamped, so zeta is 0.5. Then resonance frequency formula omega r, omega n root 1 minus 2 zeta square, whether it is standard or not, omega r remains to be the same. Omega r में कोई change नहीं, mr amplitude वाला हिस्सा ही फर्क पड़ेगा. This is given to be 5 root 2. From this we can solve omega n to be 10. So the transfer function of the system can be written as 5 omega n square upon SO square plus 2 zeta omega ns plus omega n square. Unfortunately, there is a print mistake. It should be 10s. Answer to the question is C, but with a correction in the question itself. Question needs correction. This question came as it is in the previous papers. I don't remember whether GATE exam or ES exam. उसमें भी वो mistake वैसा ही था और ES इंजीनियरिंग सर्विस वालों ने उसको उठा के ऐसे ही छाप दिया उसको, बगैर इसको सॉल्व किए देखे, बगैर करेक्शन के. तो it needs a correction. By considering standard notations, the peak value of the magnet, this is what 1 by 2 zeta root 1 minus zeta square. Resonance peak formula 1 by 2 zeta root 1 minus zeta square. Standard for standard second order and for unit step input. Otherwise, it will be modified. What is the phase margin of the system whose open loop transfer function is this? Phase margin of a system is 180 degree plus phase of this system at gain crossover frequency, and gain crossover frequency is that at which magnitude of the system is 1 and this omega gc becomes root 3 by solving it from here. So what is phase margin? It is 180 degree minus 90 degree minus 60 degree. This is 30 degree. Answer to the question is C. Another question about phase margin. See, to talk about phase margin, first we need gain crossover frequency, the frequency where magnitude becomes 1. देखो ये फंक्शन देखते ही पता चल जा रहा है, इसका जो मैग्नीट्यूड है ना, when omega 0 1 by 2, when omega infinity it is 0, magnitude varies from half to 0, no gain crossover frequency, because gain crossover frequency is the frequency where magnitude is 1. ये तो 1 by 2 से 0 जा रहा है, 1 कभी होगा ही नहीं. तो जब कोई गेन क्रॉसओवर फ्रीक्वेंसी नहीं होगा तो फेस मार्जिन डिफाइन नहीं कर सकते हैं, तो फिर इन्फिनिटी, ऑप्शन डी. This is also from the previous papers and this is from the workbook. I told you almost all of them there from in made is material. You might have come across if you have gone through. Which of the following is the transfer function of tachometer? Tachometer is functionally derivative controller. Our derivative controller is functionally tachometer. Derivative controller is the one which has got a 0 at origin. Direct answer it is. Open loop DC gain of a system whose closed loop transfer function is this. In case of default unity negative feedback, we can obtain the open loop transfer function from closed loop transfer function by subtracting the numerator from the denominator. This is s plus 4 upon so square plus 6s plus 9. Question is to find the DC gain of the system. Question is to the open loop transfer function of the system is coming out by subtracting the numerator from the denominator to be this. Question is to find open loop DC gain. We can do that by substituting s is equals to 0, that becomes 4 by 9. Or we can also convert that into time constant form. This question is also there in your workbook. A second order system has got the transfer function given by 25 upon s square plus 8s plus 25. It is initially at rest. Then what will be the time at which the second overshoot occurs? I think it is the same numeric that came in the question number 31, same function, but there it was to find the settling time for 5% tolerance. But here for the same function, question is to find the time at which the second overshoot occurs. See, Tp, the formula for peak time is n pi by omega d. For second overshoot, n becomes 3 from the step response. Omega n is 5, zeta is 0.8, 4 by 5, 0.8. Omega d omega n root 1 minus zeta square 5 into 0.36 0.6 5 into 0.6 5 into 0.6, that is 3. So it is 3 pi by 3. Answer to the question is pi. Option D. In this question, I mean, we need to focus a bit more. This is the last question that we got. Nyquist criteria for the stability states that an amplifier is unstable if the Nyquist curve encloses -1, 0 point, and amplifier is stable if the curve does not enclose this point, if A beta, the open loop magnitude we need to treat it to be. See, taking a typical example of a polar plot, which is integral part of the Nyquist plot, and taking this to be the point -1, 0. Actually, the wording, it's a blend of amplifier concepts of analog electronics and control system, but of course we need to mainly deal with the Nyquist criteria things. Say this, if this is -1, 0 point, and if this is the polar plot of a system, now -1 is not encircled. It is not inside, right, outside. It is not encircled, and now it is to the left side of the polar plot, stable system. Suppose if this happens to be the polar plot of the system, now -1 is encircled, and hence the system becomes unstable because it comes to the right side of the polar plot. That's what mentioned in the question. The question is about the condition that we need to impose on the A beta, which I take it to be mod GH at omega PC. इसको ना magnitude of the open loop transfer function at omega PC, इसकी बात करता हूँ. See, -1, 0 polar plot के left में है stable. इसका मतलब if I call this to be that minus A beta greater than -1, that means A beta less than 1. That's why the system is stable. This is unit circle. This is the unit circle. In order to comment on the stability of the system, any gain margin, phase margin calculate करके भी, probably this is the circle that he is referring to in the question, right? In case of stable systems, you see this A beta that will be inside this circle. In case of negative feedback, see, -1, 0 will be the reference point in the stability analysis in case of negative feedback, and 1, 0 will be the reference point in the stability analysis of positive feedback. तो बात नेगेटिव फीडबैक की ही हो रही है और सब में नेगेटिव ही तो है. So I say that this minus, because of lack of the clarity in the question, lot of confusing language is used. Minus A beta, I treat it to be, it lies inside this circle with 1 plus A beta less than 1. So if A beta less than 1, 1 plus A beta I can say less than 2. If A beta less than 1, 1 plus A beta less than 2. If 1 plus A beta less than 2, it is anyhow less than 1. If a value is less than 2, it is anyhow less than 1. अगर कोई value 2 से कम है तो वो 1 से तो कम है ही ना. Right. I'm sorry. Let me take my words back. I take my words back. Not necessary. If it is less than 1, then it is less than 2. So I mean to say, the condition is, I need to say it reverse. If he says that 1 plus A beta is less than 1, then it is anyhow less than 2. अगर कोई value less than 1 है, तो फिर वो value less than 2 तो ज़रूर होगा क्योंकि 1 is anyhow less than 1. So the best, still the benefit of the doubt, the best option among these 4 looks to be option B. That's all about it. Hope you might have done the same way, except maybe 1 or 2 questions. I wish you all the best for your future perspectives. God bless.
Welcome to the digital electronics session, my dear students. We are going to have the discussion of now the questions given in the digital electronics. Here the questions are so simple they give, we can handle those very in a simple manner. You know, just look at this one. It is a priority encoder, where the priority encoder means you know very well about it. Generally we used to have the discussion about it in our classes also, where for example we are having like this 4 inputs, this is I3, this is I2, this is I1, this is I0, and here the 2 outputs, this is Y0 and this is Y1. Now the table related to that we can say as I3, I2, I1, I0. Here it is nothing but Y1, Y0 like this. In the case of priority encoder, at a time not a single particular input, number of inputs if they are activated, then what will be the output is among the activated inputs the highest number, that related output we are going to get. That is the basic operation of the priority encoder. Here the priority is giving to the highest number, isn't it? In based on that the table if you are trying here, we are going to get here if it is activated at that time, that means when it is activated, this should not be activated at that time, we will get this I0 related code here. When I1 is activated and at that time when I1 is activated, then above when I1 is activated, above these two should not be activated and I0 may activate or not, then we should get I1 related code. In the same manner, when I2 is activated here, the above number, when I2 is activated, if the above number is not activated, then below the numbers may activate or not, that is different, then we should get that particular code. When this is activated and these are activated or may not activated, you will get this is the result. Based on that, if you write the equation Y0 is nothing but we are going to get here Y0 is nothing but this is I1, where this I2 bar dot I3 bar plus this is nothing but I3. Check it how we wrote the equation. This is I1 and this I2 should be 0, that should be indicated with I2 dash, and I3 is also should be 0, that is indicated with I3 dash, plus this one related I3 you should write it. Following now? Like that. Here Y1 when you are having this is, for this one how we are going to get the equation is here 1. So, that is nothing but here I2 and this is I3 dash, like that this is going to be I3. So, this is the way you should write it, and of course, the simplification of this one can be of I2 plus I3 we are getting, where they gave the name actually the notation in the form of D0, D1, D2, D3 like that, no. So, this is D0, D1, D2, D3 like that. So, that this Y1 they are saying as it is nothing but X and it is the Y. So, X is going to be I2 plus I3, that means nothing but D2 plus D3. So, that related one is going to be the option A, we are going to get it. Got it this? Right. Now, check it this one, next one we can have. How many flip flops are required to build a binary counter that counts from 0 to 4095? Generally for any counter, you know, in general if they are asked about the counter, when it is not ring counters are having a specific another formula, but in general when you are having the counters formula, we know we are going to have n flip flops to power n number of possible states we are going to get it. So, for example, if you are taking n is equal to 12 here, then 12 means 2 power 12 we are going to get here 4096. So, based on that we can check it the answer here, because the formula is n flip flops means 2 power n number of states mod value we are going to get it. So, simple thing it is also, isn't it? Right. Now, come to this one here 2-bit binary multiplier. It is a direct circuit, a direct combinational circuit which consists of, which is going to have 2 half adders and here 4 AND gates with 2 inputs. It is a direct question for this one also, you can say that, isn't it? Right. Now come to this one here. Here a binary half subtractor you know very well, that is we are having, this is AB 0 0 0 1 1 0 1 1. Here the difference is going to be, 0 1 1 0, and here the borrow is going to be, we will have here 0 minus 1 case, in this we will get 1 and other cases are 0. So, related to this one, if you write here, we will get this is A bar B and this is nothing but A B bar. So, that difference is nothing but A bar B plus A B bar. Like that, borrow, if you want to check it, how we are going to get, this borrow is going to be A bar B. So, based on that, the correct option will be here A B bar plus A bar B, A B bar plus A bar B and x equal to A bar B. This is the option C. Okay, we can check that one. It is so simple one, no? Check that. That is the question number 22. Next, another question is here. Yeah, always I used to say one table you should read and go to the exam, that is the noise margin, propagation delay, power dissipation. For all the logic families, you should just check it and you should go to the exam. Always I used to give a note point also to you. Based on that only they gave a question here where ECL has the least propagation delay because it is actually having high speed operation. Okay, right. Now, next one you can say here. Yeah, consider this is nothing but they are asking the division here 0 1 0 0 0 0 0 and divisor is 0 1 1 0. You just convert these very simple short technique, what you know in this one. You can take this one as directly the decimal value and this is also the decimal value. So, based on that if we divide it, where we are going to get the option is nothing but here 0 1 0 1 will be the quotient and remainder will be the 0 0 1 0, we are going to get it. Okay, right, because if you convert this one, this is going to be what? This is going to be 6, and like that if you also convert this into the decimal and divide that one, we are going to have 32 by 6, then we will have the remainder is going to be 2 and the quotient is going to be the 5. So, that is the thing. Now, here the maximum conversion time for this counter type ADC, it is a direct question, 2 power n minus 1 cycles it will be, isn't it? Right. All these are very simple and direct questions we are having. So, you can handle these in a very simple, very less time also you can handle these questions. As I said always to you, some important topics from where you can expect the questions, from there only they gave, that in a very simple manner they gave, and you can handle these also in a very simple way. Okay, right. Thank you.
Good evening, students. So, for the ESE 2023 questions of advanced communication systems. So, the first question, the frequency range for the broadcast satellite services. So, we have totally 3 types of satellite services are there. The first one is MSS, which is called as mobile satellite service. And the second one is called as FSS, which is called as fixed satellite service. It is a fixed satellite service. And the third one is, it is BSS. It is BSS. BSS stands for the broadcast satellite service. So, already we studied about the microwave frequency bands in the satellite. So, L, S, C, X, Ku, K, Ka, all these bands. So, if you talk about the MSS, we use the L band, and FSS, fixed satellite service, obviously knows for the students it is C band, which is equal to 4 to 8 gigahertz. C band is used, and the broadcast satellite service, we are using the band called as Ka. Ka will present from 12.5 to 18 gigahertz, and we also use another band that is called K band, that is from 18 to 27, that is 26.5 gigahertz, which is 26.5 gigahertz, that is 26.5 gigahertz is the band. So, if you talk about the broadcast satellite service, that is asking the question broadcast satellite service frequency range was asking. That means used in the 2 bands, one is Ka and other one is called as the K band. So, the 2 bands it is used. So, the frequency range was present from 12.5 to 26.5 gigahertz. So, many students will think such that the C band was mostly used 4 gigahertz to 8 gigahertz, they think the answer is this one, but the answer is the D. D is the correct answer for this question, because you are asking about the broadcast satellite service, you was asking. Then we can go for the next question. So, in the next question, in an advanced mobile phone system, if you see in an advanced mobile phone system, amps, which of the following separate channels in a link are used? So, which technique was using? Multiple axing technique for separating the channels. This is the question he asked. So, if you see here clearly, advanced mobile phone system, if you talk about advanced mobile phone system, we know that in mobile communication, obviously we studied in mobile communication about the generations. So, if you see about the generation that is called as the first generation mobile is called as the amps. Okay, analog mobile phone system, which uses analog system. We already discussed in the classroom about the list of amps and first generation, second generation, third generation and fourth generation, and 5G also. What's the techniques we use in the 5G also. Now, if you see here clearly, first generation amps analog mobile phone system, it is using a multiple axis technique called as FDMA, frequency division multiple axis technique. Only amps. See in the question, he was asking advanced mobile phone system, only amps. That is what uses the FDMA, FDMA only, that is FDMA only it will be used. If you come to the second generation, in second generation we are going to be having 3 types DAMs. DAM stands for the digital mobile phone system, that is digital analog mobile phone system, the DAMs, and next one is GSM, global system for mobile communication. The third one is CDMA, the code division multiple axis. So, if you talk about the DAMs, in DAMs we use FDMA and TDMA, both will be used in the DAMs. For transmission of your digital, we definitely require the TDMA, that is a time division multiple axis. Now, in GSM, we are also using the both FDMA and TDMA is also used in the GSM. And if you talk about the CDMA itself indicates it's the code division multiple axis, interim service IS 95, the code division multiple axis. So the answer, if you see here, asking for the amps, only for the amps, it is FDMA, frequency division multiple axis. Okay. So these are the only questions. There are 2 questions asked from the advanced communication systems. Okay. So we can see the solutions for the next subject. Thank you.
नमस्कार। उम्मीद है आप सभी लोगों का पेपर बहुत अच्छा हुआ होगा। ईडीसी से इस बार काफ़ी क्वेश्चन पूछे गए हैं इंजीनियरिंग सर्विसेज में, और जो भी क्वेश्चंस हैं थोड़ा सा कैलकुलेटिव हैं, कई क्वेश्चन तो गेट के प्रीवियस ईयर हैं। सो मैं और कामेश सर डिस्कस करेंगे वन बाय वन एक एक क्वेश्चन आपके साथ। तो पहले क्वेश्चन से शुरू करते हैं। फर्स्ट क्वेश्चन है द लॉन्गेस्ट वेवलेंथ दैट कैन बी अब्जॉर्ब्ड बाय द सिलिकॉन व्हिच हैज द बैंड गैप ऑफ 1.12 इलेक्ट्रॉन वोल्ट इज 1.1 माइक्रोमीटर। इफ द लॉन्गेस्ट वेवलेंथ दैट कैन बी अब्जॉर्ब्ड बाय द अनदर मटेरियल इज 0.87 माइक्रोमीटर, देन द बैंड गैप ऑफ दिस मटेरियल इज। ये क्वेश्चन वर्कबुक में भी है, आप सभी को आंसर हो सकता है याद भी हो, सॉल्व भी ना करना पड़े, फिर भी कर लेते हैं। सो एब्जॉर्ब होने के लिए द एनर्जी ऑफ द फोटॉन शुड बी ग्रेटर देन आर इक्वल टू बैंड गैप। ये जानते हैं आप सभी, तभी फोटॉन एब्जॉर्ब होगा। सो लेमडा शुड बी लेस देन आर इक्वल टू एच सी अपॉन ई जी। ठीक, लॉन्गेस्ट के लिए इक्वलिटी ले लेंगे, सो इक्वल वैल्यू एच सी अपॉन ई जी। मैंने कहा था कि ईएस के लिए ही आपको कहा था कि इसको याद रखिएगा, इट इज 1.24, दिस वैल्यू इज 1.24 एंड ईजी को आप इलेक्ट्रॉन वोल्ट में पुट कर दीजिए, इन इलेक्ट्रॉन वोल्ट, देन दिस विल कम इनटू माइक्रोमीटर। लेमडा की वैल्यू माइक्रोमीटर में आ जाएगी। आप चाहें तो इसको सॉल्व भी कर सकते हैं। पहला डेटा जो दिया हुआ है वो एचसी की वैल्यू को कैलकुलेट करने के लिए ही दिया हुआ है। आप डायरेक्ट करें इसको, क्लास में भी मैं आपको डायरेक्ट ही सलाह देता हूं, इतना ज्यादा फर्जी कैलकुलेशन करने की जरूरत है नहीं, ये रिलेशन सबको याद रहता है। सो ईजी अगर आपको निकालना है तो 1.24 अपॉन लेमडा इन माइक्रोमीटर। लेमडा इन माइक्रोमीटर आपको दिया हुआ है एंड दैट वैल्यू इज 0.87। सो 1.24 अपॉन 0.87 रफली अराउंड 1.42 इलेक्ट्रॉन वोल्ट। नियरेस्ट ऑप्शन चुन लीजिए, 1.42 इलेक्ट्रॉन वोल्ट का कौन सा है, 1.416। सो इट विल बी ऑप्शन ए। इस क्वेश्चन के लिए जो राइट आंसर होगा वो ऑप्शन ए होगा। बाकी आपको जो दूसरी वैल्यू दी हुई अगर उससे भी करना चाहें तो आप वहां से भी कर सकते हैं, कोई फायदा नहीं है, डायरेक्टली ऐसे करने की कोशिश करिए। नेक्स्ट क्वेश्चन सर। The band gap of germanium at room temperature is, याद होगा आपको, रूम टेम्परेचर पर 0.712 इलेक्ट्रॉन वोल्ट, so approximately 0.7 इलेक्ट्रॉन वोल्ट, that is given by option B. So right choice for this question is option B. ठीक है।
Now question number 3 is the silicon is doped with boron to a concentration of 4 into 10 to power 17. बोरॉन से डोपिंग किया है तो definitely this is the acceptor doping concentration 4 into 10 to power 17 and this is in the per centimeter cube. ये डोपिंग गिवन है और इंट्रिंसिक कैरियर कॉन्सेंट्रेशन Ni का जो वैल्यू गिवन है दैट Ni वैल्यू इज 1.5 into 10 to the power of 10 इन पर सेंटीमीटर क्यूब। नाउ इस क्वेश्चन में क्या पूछा गया है कि Kt की वैल्यू गिवन है आपका, Kt या आप Vt बोल रहे हैं, उसकी वैल्यू गिवन है 25 मिली वोल्ट या आप बोल सकते हैं 0.025 वोल्ट गिवन है आपका। आपको निकालना है कंपेयर टू अनडोप्ड सिलिकॉन। अनडोप्ड मींस इंट्रिंसिक सिलिकॉन के कंपैरिजन में फर्मी लेवल डोप्ड सिलिकॉन का कहां लाई करेगा। अब आप देखो Na है आपका तो डेफिनेटली सेमीकंडक्टर क्या बनेगा आपका, पी टाइप बनेगा और पी टाइप सेमीकंडक्टर में डेफिनेटली फर्मी लेवल कहां होगा, इंट्रिंसिक से नीचे होगा। आपको कैलकुलेट क्या करना है कि जो पी टाइप का फर्मी लेवल है वो इंट्रिंसिक फर्मी लेवल से कितना डाउन होगा, तो दैट इज EFI माइनस EFP जो कि होगा आपका KT नेचुरल लॉग ऑफ डोपिंग कॉन्सेंट्रेशन Na डिवाइड बाई Ni। डेफिनेटली अगर आप वैल्यू पुट करो 0.025 एंड ln ऑफ Na का वैल्यू पुट करें 4 into 10 पावर 17 डिवाइड बाई Ni का वैल्यू फिट कर दें हम 1.5 into 10 पावर 10। इसको सॉल्व करने के बाद अगर आप आंसर देखेंगे तो ये आएगा 0.427, ओके 0.427 इलेक्ट्रॉन वोल्ट और ये आपका फर्मी लेवल जो है वो इंट्रिंसिक से नीचे है। तो कंपेयर टू अनडोप्ड सिलिकॉन पूछा है तो इट इज विल गोज डाउन बाय 0.427 इलेक्ट्रॉन वोल्ट और ये बहुत रिपीटेड क्वेश्चन है। आप देखेंगे तो ये सारे ऑप्शंस के साथ भी प्रीवियस ईयर बुक्स में गिवन होगा डेफिनेटली।
ये KT बाई Q की वैल्यू है तो वहां से KT निकालेंगे तो 25 मिली इलेक्ट्रॉन वोल्ट आ जाएगा।
ओके सो KT हो या KT बाई Q हो, डोंट टेक केयर ऑफ इलेक्ट्रॉन वोल्ट और वोल्ट, बोथ आर सेम। ओके Okay, so the resistivity of a uniformly doped n-type silicon sample is 0.5 ohm into centimeter. This is given. So resistivity is given. Resistivity is वो भी n-type semiconductor का given है आपका, that is 0.5 ohm and centimeter. If the electron mobility is given mu n and the charge of the electron is given, the donor impurity concentration in the sample is, देखो सैंपल जो आपका n टाइप है, अगर हम n टाइप की कंडक्टिविटी की बात करें तो कंडक्टिविटी होता है nq mu n अप्रोक्सीमेटली, बिकॉज होल्स का कॉन्सेंट्रेशन आपका माइनर होता है इन n टाइप सेमीकंडक्टर। अगर मैं n की बात करूं, इसको अप्रोक्सीमेटली करूं तो इलेक्ट्रॉन कॉन्सेंट्रेशन इज अप्रोक्सीमेटली इक्वल टू डोनर एटम्स कॉन्सेंट्रेशन nd इंटू q इंटू म्यू n। ओके, सो ये आपको रफ कैलकुलेशन करना है। अब कंडक्टिविटी इज 1 अपॉन रजिस्टिविटी एंड दैट इज nd इंटू क्यू इंटू म्यू एन। अब आपको यहां से nd का वैल्यू निकालना है तो nd इक्वल टू आ जाएगा 1 अपॉन रो n इंटू क्यू इंटू म्यू एन। ओके, रजिस्टिविटी की बात करें तो रजिस्टिविटी का वैल्यू गिवन है 0.5 ओम इंटू सेंटीमीटर, यूनिट्स का हमेशा केयर रखना है, सेंटीमीटर में प्रॉपर। क्यू की वैल्यू 1.6 इंटू 10 पावर माइनस 19 एंड मोबिलिटी की बात करें तो वो भी देखो सेंटीमीटर में है, 1250 सेंटीमीटर स्क्वायर पर सेकेंड। अब इसको कैलकुलेट करें तो nd का आंसर कितना आएगा सर बताइए, 1 इंटू 10 पावर 16। ओके, सो 1 इंटू 10 पावर 16 पर सेंटीमीटर क्यूब ये आपकी वैल्यू आएगी, जो कि आपको ऑप्शन बी में दिख रहा है। तो इस क्वेश्चन के लिए ऑप्शन बी आपका करेक्ट हो गया। ओके,
नेक्स्ट क्वेश्चन देख लेते हैं. नेक्स्ट क्वेश्चन इज अ सिलिकॉन सैंपल ए इज डोप्ड विद दिस मच ऑफ एटम्स ऑफ बोरान. सो ए सैंपल ए के बारे में अगर बात करें तो इसमें बोरान की डोपिंग कर रहा है. ठीक है. सो बोरान का मतलब एक्सेप्टर कंसंट्रेशन इज गिवन दैट इज 10 to the power 18 एटम्स पर सेंटीमीटर क्यूब. सो मैं पर सेंटीमीटर क्यूब लिख दे रहा हूं. अनदर सैंपल बी ऑफ द आइडेंटिकल डायमेंशंस. सो आइडेंटिकल डायमेंशन का एक दूसरा सैंपल ले रहा है, सैंपल बी, और इसमें डोपिंग कर रहा है डोप्ड विद फास्फोरस. फास्फोरस का मतलब डोनर. सो ये एन टाइप बनेगा. फर्स्ट सैंपल पी टाइप बनेगा, सेकंड सैंपल आपका एन टाइप बनेगा. एंड डोनर कंसंट्रेशन इज आल्सो सेम 10 to the power 18 पर सेंटीमीटर क्यूब, एटम्स पर सेंटीमीटर क्यूब. ठीक. द रेशियो ऑफ इलेक्ट्रॉन टू होल मोबिलिटी इज गिवन एज 3. So mu n upon mu p, this value is given as 3. The ratio of conductivity of sample A to the conductivity of sample B. तो sample A में acceptor की doping है, so it will become p type. So conductivity, let us assume that is sigma p, right? And B is doped with phosphorus, so it will become n type. So conductivity is, let us suppose, sigma n. कह रहा रेशियो ऑफ कंडक्टिविटी ऑफ सैंपल ए टू द कंडक्टिविटी ऑफ सैंपल बी, सिग्मा ए अपॉन सिग्मा बी, दैट इज सिग्मा पी अपॉन सिग्मा एन. सिग्मा पी इज अप्रॉक्सीमेटली Na Q mu p अपॉन सिग्मा एन इज अप्रॉक्सीमेटली Nd Q mu n. ये वैल्यूज आपके पास अवेलेबल हैं. आप देखिए Na और Nd सेम है. सो Na और Nd अगर सेम है, वैल्यू पुट करोगे कैंसिल हो जाएगा. सो दिस विल कैंसिल, ये दोनों कैंसिल हो करके आपके पास आ जाएगा म्यू पी अपॉन म्यू एन. द गिवन वैल्यू इज म्यू एन अपॉन म्यू पी. सो म्यू पी अपॉन म्यू एन विल बिकम 1/3. 1/3 का मतलब ऑप्शन बी. सो राइट चॉइस फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन बी. इसके लिए आंसर हो जाए. इस तरह का क्वेश्चन भी हम लोगों ने क्लास में किया हुआ है, वर्कबुक में इस तरह तमाम क्वेश्चन है. तो बहुत ही सिंपल क्वेश्चन था. थोड़ा सा इस बार क्या है कि आपको कैलकुलेशन करना पड़ रहा है. स्ट्रेट फॉरवर्ड क्वेश्चन नहीं है कि जस्ट देख करके या थ्योरेटिकल आंसर. According to the Einstein relation for any semiconductor, the ratio of diffusion constant to mobility. Einstein relation क्या होता है? D by mu is equal to Vt, and Vt is what? Kt by Q, thermal voltage. So K by Q is constant, so it will increase with temperature. It means it varies with the temperature. So depends upon the temperature of the semiconductor. So answer will be option A. So right choice for this question is given by option A. इस question के लिए option A. Straight forward. बाकी और कुछ देखने की भी जरूरत नहीं है.
Okay, so this is some calculative question. A heavily doped n-type semiconductor has the following characteristics. Hole electron mobility ratio, मतलब क्वेश्चन में गिवन है होल्स और इलेक्ट्रॉन की मोबिलिटी का जो रेशियो है वो 0.4 वैल्यू गिवन है आपका. ओके. डोपिंग कॉन्सेंट्रेशन एन टाइप बोला है, तो डोपिंग कॉन्सेंट्रेशन मींस एनडी का वैल्यू गिवन है आपका 4.2 × 10 to the power of 8. ओके, इन पर मीटर क्यूब. मीटर क्यूब में यूनिट्स आपकी गिवन है, इसका बात का केयर करना है. इंट्रिंसिक कैरियर कॉन्सेंट्रेशन की बात करूं तो एनआई भी आपका किस में गिवन है? मीटर में ही गिवन है. तो 1.5 × 10⁴ मीटर क्यूब. अब बेटा यहां से अगर हम देखें, यहां से देखें हम, तो ये आपका एक एन टाइप सेमीकंडक्टर है, तो इलेक्ट्रॉन का कॉन्सेंट्रेशन अप्रोक्सीमेटली क्या होगा? एनडी के बराबर, जो कि आपका हो जाएगा 4.2 × 10⁸. अगर आप होल्स का कॉन्सेंट्रेशन निकालने की कोशिश करें तो ni²/n आप मास एक्शन लॉ लगाएंगे, तो यहां से देखें अगर मैं ni का स्क्वायर करूंगा तो ये आएगा 2.25 × 10 to the power of 8 डिवाइडेड बाई n की वैल्यू पुट करूंगा 4.2 × 10⁸. अब आप यहां से क्लियरली देख सकते हैं 10⁸ से 10⁸ कैंसिल होगा, ये वैल्यू बहुत नेग्लिजिबल आएगी कंपेयर टू इलेक्ट्रॉन कॉन्सेंट्रेशन. तो ये वैल्यू बहुत नेग्लिजिबल आ रही है, इसके बारे में हमें केयर ही नहीं करना है, नेग्लिजिबल आ रहा है. ओके, अब क्वेश्चन को आगे देखते हैं. द रेशियो ऑफ कंडक्टेंस ऑफ एन टाइप टू द इंट्रिंसिक वी हैव टू कैलकुलेट. कंडक्टेंस क्या होता है आपका? G ऑफ एन टाइप डिवाइड बाई G ऑफ इंट्रिंसिक वी वांट टू कैलकुलेट. केयर करना है, कंडक्टेंस पूछा है, कंडक्टिविटी नहीं. वो बात अलग है कि इसका रेशियो कंडक्टिविटी के रेशियो के बराबर आएगा, लेकिन होश में हमेशा रहना है. तो Gn/Gi निकालूं मैं तो कंडक्टेंस 1 रेजिस्टेंस होता है, तो दिस इज 1 रेजिस्टेंस ऑफ एन टाइप डिवाइड बाई 1 रेजिस्टेंस ऑफ इंट्रिंसिक. तो ये रेशियो क्या आ जाएगा? इंट्रिंसिक सेमीकंडक्टर का रेजिस्टेंस डिवाइड बाई एन टाइप का रेजिस्टेंस. आपको पता है रेजिस्टेंस R = ρl/a होता है, तो R आपका प्रोपोर्शनल होता है रेजिस्टिविटी के. अब L और A को क्यों कंसीडर नहीं कर रहा हूं? बिकॉज सेम मटेरियल के बारे में बात कर रहा है, तो L चेंज नहीं होगा, एरिया चेंज नहीं होगा, तो रेजिस्टिविटी के ये प्रोपोर्शनल है. इसलिए मैं बोलूं कि Gn/Gi निकालूं, दैट इज Ri/Rn है आपका. इसका मतलब ये हो गया कि ये रेजिस्टिविटी का रेशियो हो गया रो आई अपॉन रो एन, क्योंकि आर रजिस्टिविटी के प्रोपोर्शनल है। रजिस्टिविटी कंडक्टिविटी का रेशियो रिलेशन पता है हमें, रजिस्टिविटी कंडक्टिविटी के इनवर्सली प्रोपोर्शनल होता है, इसलिए मैं अब लिख सकता हूं सिग्मा एन अपॉन सिग्मा आई। तो यहां से एक बात क्लियर हुआ आपका कि कंडक्टेंस का रेशियो निकालेंगे वो कंडक्टिविटी के रेशियो के बराबर आ रहा है, बिकॉज एल एंड ए चेंज नहीं हो रहा है इसलिए। ठीक है, चलो अब हम आपको सिग्मा एन अपॉन सिग्मा आई निकालना है हमको फाइनली, तो जी एन अपॉन जी आई जो हमें निकालना है वो सिग्मा एन अपॉन सिग्मा आई है। तो आपको पता है कि एन टाइप की कंडक्टिविटी क्या होती है, एन क्यू म्यू एन, सो एन क्यू म्यू एन, ओके, डिवाइड बाय इंट्रिंसिक सेमीकंडक्टर कंडक्टिविटी क्या होता है, एन आई इंटू क्यू ब्रैकेट म्यू एन प्लस म्यू पी, ये कंडक्टिविटी होता है। सो मैंने सिग्मा एन एन क्यू म्यू एन लिखा है बिकॉज होल्स का कॉन्सेंट्रेशन नेग्लिजिबल है इसलिए। अब आपको पता है कि एन का वैल्यू गिवन है, क्यू से क्यू कैंसिल आउट होगा। अब देखो ऊपर म्यू एन है और हमारे पास रेशियो ऑफ मोबिलिटी गिवन है, तो नीचे से क्या करूंगा मैं, डिनोमिनेटर से म्यू एन कॉमन लूंगा, तो नीचे बन जाएगा 1 प्लस म्यू पी बाई म्यू एन, ये बन गया आपका फैक्टर। जब ये फैक्टर बन गया आपका तो अब ये इजी हो जाएगा आपका। देखो अब Q से Q तो कैंसिल हो ही चुका था आपका, अब म्यू एन से म्यू एन कैंसिल हो गया, ये आ गया इलेक्ट्रॉन कॉन्सेंट्रेशन अपॉन एन आई ब्रैकेट 1 प्लस म्यू पी बाई म्यू एन। यहां से सॉल्व करते हैं, सारी वैल्यूज पुट करते हैं, एन की जो वैल्यू है वो पुट करते हैं। एन का वैल्यू गिवन है आपका 4.2 इंटू 10 पावर 8, 4.2 इंटू 10 टू द पावर ऑफ 8, और एन आई का जो वैल्यू गिवन है आपका वो 1.5 इंटू 10 पावर 4 गिवन है। ब्रैकेट में 1 प्लस म्यू पी बाई म्यू एन करूंगा तो म्यू पी बाई म्यू एन इज 0.4, ओके। अब इसको अगर मैं कैलकुलेट करूं, आप आफ्टर कैलकुलेशन अप्रोक्सीमेटली आ जाएगा 20 इंटू 10 टू द पावर ऑफ 3, यस।
ठीक, जिन लोगों ने मुझसे पढ़ा होगा ये वर्कबुक का क्वेश्चन है क्लास में, तो मैं वहां पर इतना कैलकुलेशन ना करा करके एक सिंपल लाइन आपको लिखाता हूं कि कंडक्टेंस इज रेसिप्रोकल ऑफ रेजिस्टेंस एंड रेजिस्टेंस इज डायरेक्टली प्रोपोर्शनल टू रेजिस्टिविटी, हेंस कंडक्टेंस इज डायरेक्टली प्रोपोर्शनल टू कंडक्टिविटी। तो जो फाइनल रिजल्ट आया सर का वो डायरेक्टली मैं यहां से लिखा करके एंड देन ये रेशियो हम लोगों ने कैलकुलेट किया। वर्कबुक का क्वेश्चन आपने किया होगा, वहां भी आंसर वहां 20,000 लिखा था, यहाँ 20 इंटू 10 रेज़ पावर 3 है, सेम क्वेश्चन है। सो आंसर इज ऑप्शन।
इस बार सबसे स्पेशल बात ये दिख रहा है आपको गेट के ESE क्वेश्चन में कि सारे के सारे प्रीवियस ईयर क्वेश्चंस को उठाया गया है, बिल्कुल, मतलब आप वर्कबुक ऐसा फील हो रहा होगा आप वर्कबुक सॉल्व कर रहे हैं आप मेडीजी का, ओके।
नेक्स्ट क्वेश्चन भी वर्कबुक का ही क्वेश्चन,
इसमें भी देखो ये पूरा का पूरा डेटा सहित, मतलब ऑप्शंस आप देख रहे होंगे ना, वो पूरा का पूरा प्रीवियस ईयर का है। अब आपको देखो ये बहुत सिंपल क्वेश्चन है, एनडी का वैल्यू गिवन है, तो इलेक्ट्रॉन का कॉन्सेंट्रेशन इक्विलिब्रियम में अप्रोक्सीमेटली किसके बराबर होगा, एनडी के, जो कि 2.25 इंटू 10 टू द पावर ऑफ 15 है पर सेंटीमीटर क्यूब में। और ऐसा क्यों किया, देखो एनडी की वैल्यू एनआई से बहुत ज्यादा है। अगर एनडी की वैल्यू मच ग्रेटर देन एनआई होता है आपका, मच ग्रेटर देन एनआई है, तो आप आराम से अप्रोक्सीमेट कर सकते हैं एन इज अप्रोक्सीमेटली एनडी। और इस क्वेश्चन में कैलकुलेट करने की जरूरत नहीं थी, बहुत लॉजिक से क्वेश्चन हो जाएगा। देखो आपका ये एनडी गिवन है, तो डेफिनेटली एक एन टाइप सेमीकंडक्टर में एन की वैल्यू ग्रेटर देन एनआई होती है और पी की वैल्यू लेस देन क्या होगी, एनआई होगी। और ये केवल एक ऑप्शन में सेटिस्फाई हो रही होगी, एन की वैल्यू ग्रेटर देन एनआई, मतलब 1.5 इंटू 10 पावर 10 से ज्यादा होनी चाहिए एन की वैल्यू। वो आपको दो ऑप्शन में दिख रहा है, देखो सी एंड डी में। होल्स के कॉन्सेंट्रेशन की वैल्यू 1.5 इंटू 10 पावर 10 से कम होनी चाहिए, 1.5 इंटू 10 पावर 10 तो यहां दिख रहा है और ये उससे कम दिख रहा है। देखो डी आंसर यहीं से बन गया, आपको सॉल्व करने की जरूरत नहीं। तो लेकिन फिर भी देखते हैं, एन इज अप्रोक्सीमेटली दिस मच। अगर मैं पी की बात करूं तो पी कितना आ जाएगा, एन आई स्क्वायर अपॉन इलेक्ट्रॉन कॉन्सेंट्रेशन कर दूं इक्विलिब्रियम होल्स कॉन्सेंट्रेशन के लिए, एन आई स्क्वायर हो जाएगा 2.25 इंटू 10 टू द पावर ऑफ 20, क्योंकि स्क्वायर कर दिया मैंने एन आई का, डिवाइड बाई एन नॉट करूंगा तो 2.25 इंटू 10 टू द पावर ऑफ 15। यहां से सॉल्व करेंगे तो 10 टू द पावर ऑफ 5 आपका पर सेंटीमीटर क्यूब में होल्स का कॉन्सेंट्रेशन आ जाएगा, जो कि आपको सिंपली आप बोल सकते हो ऑप्शन डी इज करेक्ट, ओके।
Next question. In an open circuited step graded junction, the left half of the bar is P type. Open circuited PN junction कह रहा है, step graded, ठीक है। So हम लोग नॉर्मल PN junction जो पढ़ते हैं वो step graded ही पढ़ते हैं, ठीक। Open circuited means it is like this, ठीक। Left half of the bar is P type, so P type and doping concentration he is giving Na. Then whereas the right half of the N type doping concentration he is giving Nd, ठीक। In this type of doping the density changes abruptly from P to N type, that is abrupt PN junction, उसे ही step graded PN junction कहते हैं। What is the contact difference of potential? मैंने कहा था कि built in potential को contact potential भी कहते हैं, ठीक है। So basically he is asking built in potential, आपको कुछ भी करने की जरूरत नहीं, contact potential is equal to KT by Q ln Na Nd अपॉन Ni स्क्वायर, ये सभी को याद रहता है, ठीक है। KT बाई क्यू को हम लोग थर्मल वोल्टेज BT कहते हैं, ठीक। हो सकता है मैंने क्लास में मैं कई बार इसे BTH दिखाता हूं, नोटेशन से आपको कंफ्यूज होने की जरूरत नहीं है, ज्यादातर क्लास में BT ही लिखते हैं। सो Ni स्क्वायर दैट इज गिवन इन ऑप्शन डी, सो राइट चॉइस फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन डी। इसके लिए आंसर हो जाएगा आपका ऑप्शन डी।
और इसमें एक बात और ध्यान रखना है इस क्वेश्चन में, जैसे ऑप्शन सी भी कई लोगों को सही दिख रहा होगा, लेकिन इस क्वेश्चन में अंतर क्या है, यहाँ पर वीटी मिसिंग है, थर्मल वोल्टेज। अगर वीटी होता तो फिर ऑप्शन सी भी करेक्ट बन रहा होता।
ओके क्योंकि देखो नोटेशन में ये हम लोगों को बताया गया होगा, हमने आपको बताया कि पी पी नॉट यानी पी साइड पर पी, सो पी साइड पर पी अंडर इक्विलिब्रियम दैट इज मेजॉरिटी कैरियर कंसंट्रेशन व्हिच इज अप्रॉक्सिमेटली इक्वल टू Na, सो पी पी नॉट Na आ जाएगा, पी एन नॉट एन साइड पर पी, एन साइड पर पी मींस माइनॉरिटी कैरियर, सो एन साइड पर होल्स क्या हो जाएंगे, पी एन नॉट इज इक्वल टू
Ni
स्क्वायर अपॉन Nd। सो जो ln के अंदर आएगा वो NaND अपॉन Ni स्क्वायर ही आ जाएगा, लेकिन यहां पर Vt मिसिंग है, उसकी वजह से ये सही नहीं है। तो जल्दी में कंफ्यूज होकर गलत नहीं करना है, ठीक है। सो राइट आंसर इज ऑप्शन डी। नेक्स्ट चलते हैं। नेक्स्ट क्वेश्चन कह रहा है अकॉर्डिंग टू द प्रॉपर्टीज ऑफ इंट्रिंसिक सेमीकंडक्टर एट रूम टेम्परेचर द इंट्रिंसिक रेजिस्टिविटी ऑफ जर्मेनियम, रटना पड़ेगा और कोई विकल्प नहीं, या तो सारी वैल्यूज याद हो तो आप कैलकुलेट करो। सो इसमें कैलकुलेशन वगैरह हम टाइम वेस्ट नहीं करेंगे, डायरेक्टली इसकी वैल्यू 45 ओम सेंटीमीटर। आपको इंट्रिंसिक कैरियर कंसंट्रेशन जर्मेनियम की याद रहती है, ठीक है, और म्यूएन और म्यूपी याद रहता है, उससे रफली वैल्यू कैलकुलेट कर सकते हैं, बट 45 ओम सेंटीमीटर। कुछ कहना चाहेंगे क्या?
हाँ, इसमें बस आपको क्या करना है, जो वैल्यूज होती हैं स्टैंडर्ड सिलिकॉन की, जर्मेनियम की, अगर वो आपको याद है तो वेल एंड गुड। जैसे कि अगर जर्मेनियम की बात करें तो Ni का वैल्यू होगा 2.5 × 10⁻13, म्यू एन की वैल्यू 3800 एंड म्यू पी की वैल्यू 1800 होगा। उसको आप पुट करोगे, निकालोगे, 44 के अप्रोक्सीमेटली आपका रेजिस्टिविटी आएगा, दैट इज ऑप्शन सी,
रफली अराउंड। सो वैसे भी जर्मेनियम और सिलिकॉन के सारे पैरामीटर याद रखो तो ज्यादा अच्छा है इसको कैलकुलेट करना। बाकी सर ने जो बताया वो वैल्यू पुट करके आप कैलकुलेट,
स्पेशली ईएसई के लिए थोड़ा याद रखना पड़ सकता है, अदरवाइज ठीक है। अगर ये क्वेश्चन नहीं भी होगा तो क्या फर्क पड़ रहा है, इतने सारे क्वेश्चन ठीक है। अब ना क्वेश्चन नंबर 123 इज वेरी इंटरेस्टिंग। अगर आपने गेट की टेस्ट सीरीज दिया होगा मेडिजी का, तो आपको ऑगर रिकॉम्बिनेशन से रिलेटेड एक क्वेश्चन जरूर मिला होगा, जो कि टेस्ट सीरीज में मैंने सॉल्व भी कराया। सो इन ऑगर रिकॉम्बिनेशन प्रोसेस, रिकॉम्बिनेशन इन एन टाइप सेमीकंडक्टर इन्वॉल्व्स द इंटरेक्शन ऑफ। अब देखो ऑगर रिकॉम्बिनेशन होता क्या है, सिंपल, वहां से देख के आपको करेक्टली आंसर मिल जाएगा। ऑगर रिकॉम्बिनेशन प्रोसेस में ये होता है आपका कि सपोज आपका ये कंडक्शन बैंड है, ये बैलेंस बैंड है। अब ये एन टाइप की बात कर रहा है तो डेफिनेटली इलेक्ट्रॉन्स ज्यादा होंगे आपके मेजॉरिटी कैरियर, एंड होल्स आपके क्या होंगे, माइनॉरिटी कैरियर्स होंगे, किसमें, एन टाइप सेमीकंडक्टर में। अब होता क्या है कि जब सेमीकंडक्टर यूज हो रहा होता है, आपका ऑपरेशन में होता है, तो इलेक्ट्रॉन्स आपस में क्या करते हैं, कोलाइड। अब सपोज ये दोनों इलेक्ट्रॉन आपस में कोलाइड किए, अगर जैसे इलेक्ट्रॉन कोलाइड करेंगे तो एक इलेक्ट्रॉन अपनी एनर्जी ट्रांसफर करेगा दूसरे को और अपनी एनर्जी को डाउन कर लेगा। एनर्जी कंजर्वेशन यही है। तो दोनों की जो एनर्जीज है, मान लो अभी बराबर है, दोनों इंटरेक्ट किए, तो एक की एनर्जी बढ़ जाएगी और एक की एनर्जी कम हो जाएगी। जिसकी बढ़ जाएगी, सपोज इस इलेक्ट्रॉन की एनर्जी बढ़ के यहां पहुंच गई, ये हाई एनर्जी पे पहुंच गया आपका, ये इलेक्ट्रॉन आपका हाई एनर्जी पे पहुंच गया। चूंकि इसकी एनर्जी कम हो गई तो ये डेफिनेटली डाउन जाएगा और रिकॉम्बिनेशन कर लेगा। जैसे ये इलेक्ट्रॉन रिकॉम्बिनेशन करेगा, रिकॉम्बिनेशन के बाद आपको क्या मिल जाएगा, लाइट और हीट, डिपेंडिंग ऑन इनडायरेक्ट और डायरेक्ट बैंड गैप सेमीकंडक्टर। अब इस इलेक्ट्रॉन का क्या होगा, आप ये देखो, इस इलेक्ट्रॉन की कहानी तो खत्म हो गई, इस इलेक्ट्रॉन और होल्स का रिकॉम्बिनेशन हो गया। अब ये इलेक्ट्रॉन बचा रह गया जो लो एनर्जी से हाई एनर्जी पे पहुंच गया। अब ये जो हाई एनर्जी पर इलेक्ट्रॉन अवेलेबल है, तो आपको पता होना चाहिए कि जब ये इलेक्ट्रॉन कंडक्शन बैंड में हाई एनर्जी से लो एनर्जी लेवल पर आएगा कंडक्शन बैंड के, तो ये वाला जो रिकॉम्बिनेशन प्रोसेस होता है, ये वाला जो एनर्जी डिफरेंस होता है, वो हमेशा किसके फॉर्म में निकलेगा, फोनॉन। फोनॉन मतलब हीट के फॉर्म में आपका डिसिपेट होगा, निकलेगा बाहर, ठीक है। इस प्रोसेस को ही हम बोलते हैं क्या, ऑगर रिकॉम्बिनेशन प्रोसेस। नो डाउट अब ये इलेक्ट्रॉन यहां आ गया, अगर यहां पर एक होल्स अवेलेबल होगा, ये डेफिनेटली उससे जाके रिकंबाइन कर जाएगा। ये होल जो प्रोसेस है आपकी, जो लेफ्ट साइड बना हुआ है, दिस इज कॉल्ड ऑगर रिकॉम्बिनेशन प्रोसेस, जिसमें आपके दो इलेक्ट्रॉन्स हैं। अगर एन टाइप की बात करें, पी टाइप होता तो दो होल्स यहां पर बनाता है, एक इलेक्ट्रॉन बनाता, दो होल्स इंटरेक्ट करते हैं आपके, तो यहां पर दो इलेक्ट्रॉन्स ने इंटरेक्शन किया, एक रिकॉम्बिनेशन किया, एक हाई एनर्जी पे गया और फाइनली वो रिकंबाइन हो। तो 2 इलेक्ट्रॉन 1 होल्स की बात हो रही है आपकी, तो यहां पर आ गया आपका 2 इलेक्ट्रॉन एंड 1 होल्स। ओके, सो इसका ऑप्शन ए आपका करेक्ट होगा।
जिन लोगों ने मुझसे पढ़ा होगा तो मैंने ये बताया था आपको, मैं जब इम्पैक्ट आयनाइजेशन पढ़ाता हूं तो इम्पैक्ट आयनाइजेशन के वक्त हमने जो जनरेशन पढ़ा उसमें मैं ये बताता हूं कि कोई एक हाई वेलोसिटी का इलेक्ट्रॉन किसी एक एटम से टकराएगा और वहां से कोलाइड होकर के, एब्लांची मल्टीप्लिकेशन पढ़ाते वक्त ये चीज पढ़ाया हुआ है, तो इलेक्ट्रॉन, 2 इलेक्ट्रॉन जनरेट होंगे, ये प्रोसेस आगे बढ़ेगी। देन इसका रिवर्स प्रोसेस हमने पढ़ाया आपको, ऑगर रिकॉम्बिनेशन। मैंने ये कहा कि जब इलेक्ट्रॉन एटम से ना टकरा करके बल्कि इलेक्ट्रॉन से टकराए, जैसा सर ने बताया कि एक इलेक्ट्रॉन दूसरे इलेक्ट्रॉन से टकरा रहा है, तो लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम के हिसाब से क्या होगा कि एक अपना मोमेंटम लूज करेगा, मोमेंटम एंड एनर्जी लूज करेगा, और दूसरा गेन करेगा। तो इस इलेक्ट्रॉन ने एनर्जी और मोमेंटम गेन कर लिया है और इस इलेक्ट्रॉन ने लूज कर लिया। जो इलेक्ट्रॉन मोमेंटम एंड एनर्जी लूज कर रहा है वो इलेक्ट्रॉन आपका बैलेंस बैंड में चला जाकर के होल के साथ रिकंबाइन कर जाएगा और दूसरा इलेक्ट्रॉन आपका आगे प्रोसेस में पार्टिसिपेट कर रहा होगा। तो मैं आपको लाइंस लिखाता हूं, याद दिलाऊं ताकि आप अपने नोट्स में जाकर के ढूंढ लें कि व्हेन टू इलेक्ट्रॉन्स कोलाइड विद ईच अदर देन वन ऑफ द इलेक्ट्रॉन गेन्स एनर्जी एंड द अदर वन लूजेस एनर्जी आफ्टर कोलिजन। द इलेक्ट्रॉन व्हिच लूजेस एनर्जी रिकंबाइन विद द होल इन द बैलेंस बैंड, सच रिकॉम्बिनेशन प्रोसेस इज नोन एज ऑजर रिकॉम्बिनेशन प्रोसेस। तो यहां पार्टिकल कितने पार्टिसिपेट कर रहे हैं? 2 इलेक्ट्रॉन और 1 होल। अगर ये एन टाइप है, जैसा सर ने बताया, अगर पी टाइप होगा तो इसका रिवर्स हो जाएगा, 2 होल और 1 इलेक्ट्रॉन के साथ हो जाएगा। नेक्स्ट क्वेश्चन की तरफ चलते हैं।
ठीक, नेक्स्ट क्वेश्चन देखते हैं। तो नेक्स्ट क्वेश्चन में आपका दिया हुआ है, इन अ फिजिकल डायोड देयर इज अ कंपोनेंट ऑफ द रिवर्स सैचुरेशन करंट ड्यू टू लीकेज ओवर द सरफेस। द रिवर्स सैचुरेशन करंट इंक्रीजेस बाय 7% अप्रॉक्सीमेटली पर डिग्री सेंटीग्रेड राइज इन टेम्परेचर फॉर सिलिकॉन एंड जर्मेनियम। द रिलेशनशिप बिटवीन T एंड V, V मींस वोल्टेज अक्रॉस द डायोड इन VI कैरेक्टरिस्टिक। तो हमको पता होना चाहिए ये बात, आपको याद भी होगा, ये क्लासेस में जनरली डिस्कस होता है, एवरीवन टीचेस दिस कॉन्सेप्ट डेफिनेटली। तो टेम्परेचर इंक्रीज होता है तो डेफिनेटली रिवर्स सैचुरेशन करंट क्या होती है आपकी, इंक्रीज होती है, या फॉरवर्ड करंट आपकी डायोड की क्या होती है, इंक्रीज होती है। दिस इज द कॉन्सेप्ट ऑफ इंक्रीज इन करंट विद द टेम्परेचर। लेकिन अगर हम डायोड के वोल्टेज की बात करें, अक्रॉस द डायोड जो वोल्टेज होता है V, अगर उसकी बात करें, या बीजेटी में बात करते हैं VB की, तो हमें पता होना चाहिए कि जो वोल्टेज होता है डायोड के अक्रॉस dV/dt वो अप्रोक्सीमेटली 2.5 मिलीवोल्ट पर डिग्री सेंटीग्रेड राइज इन टेम्परेचर होता है, rise in temperature. Okay, in the case of silicon and germanium, in both the cases it is roughly like that. Okay, otherwise -2.3 -2.1 different value. लेकिन यहाँ से कंक्लूजन हमारा क्या निकला कि टेम्परेचर बढ़ेगा तो वोल्टेज क्या होगा, डायोड के अक्रॉस डिक्रीज होगा। अब देखना यहाँ पर 2 ऑप्शन गिवन है, टेम्परेचर इंक्रीजेस, V डिक्रीजेस, एंड सेकंड है V डिक्रीजेस एंड T इंक्रीजेस। अब आपको खुद फीलिंग्स लेकर आनी है। अगर हम एक कॉमन सेंस से देखें, वैसे ESE का कोई भरोसा नहीं है, दोनों को सही कर दे या B को सही कर दे, अपन को कोई गारंटी नहीं। लेकिन अगर लॉजिकली देखें, जो हमने सर ने डिस्कस किया लॉजिकली, कि भाई कॉज क्या है और इफेक्ट क्या है। कॉज है टेम्परेचर, जिसकी वजह से वोल्टेज का इफेक्ट आ रहा है, कि टेम्परेचर बढ़ता है तो वोल्टेज आपका डिक्रीज होता है डायोड के अक्रॉस। तो कॉज एंड इफेक्ट के हिसाब से देखें तो ए को ज्यादा सही मानेंगे हम 99.9999%। ओके,
और ये क्वेश्चन भी आप लोगों ने वर्कबुक में किया होगा, इस पर न्यूमेरिकल वर्कबुक में किया होगा, और ये बड़ा पॉपुलर फार्मूला है, सो याद रखेंगे बस। विद इंक्रीज इन टेम्परेचर वोल्टेज अक्रॉस द डायोड डिक्रीजेस, सिंपल सी बात है।
इट इज ओवर आई थिंक।
सो ये सारे क्वेश्चन हो गए ईडीसी के। ईडीसी इस बार खूब पूछी गई है, पिछले बार इतनी नहीं पूछी गई थी। तो सर थैंक यू। आप दूसरी सब्जेक्ट आप लोग देखिए। अभी थोड़ी देर बाद मैं मटेरियल साइंस के सॉल्यूशन के साथ भी आपके साथ आऊंगा।
थैंक यू।
वेलकम बैक। अब मटेरियल साइंस भी डिस्कस कर लेते हैं। मटेरियल साइंस से कम क्वेश्चन पूछे गए हैं, 4 क्वेश्चन सिर्फ पूछे गए हैं। सो देखते हैं, क्विकली देख लेते हैं उसका भी आंसर। व्हिच ऑफ द फॉलोइंग इज करेक्ट रिलेटेड टू द प्रॉपर्टीज ऑफ गुड इंसुलेटिंग मटेरियल? दिस इज द फर्स्ट क्वेश्चन। आपको याद हो तो गुड इंसुलेटिंग मटेरियल में मैं क्या पढ़ाता हूं कि उसकी डाइलेक्ट्रिक स्ट्रेंथ अच्छी होनी चाहिए ताकि ज्यादा वोल्टेज को बर्दाश्त कर सके बिना ब्रेकडाउन के। ठीक, डाइलेक्ट्रिक स्ट्रेंथ इज व्हाट? इट इज द अमाउंट ऑफ वोल्टेज टू कॉज ब्रेकडाउन इन द मटेरियल। इट मींस इट इज द मैक्सिमम वोल्टेज पर यूनिट थिकनेस ऑफ द मटेरियल व्हिच इट कैन विथस्टैंड विदाउट ब्रेकडाउन। सो आप चाहोगे कि ये मैक्सिमम वोल्टेज बर्दाश्त कर सके, यानी डाइलेक्ट्रिक स्ट्रेंथ शुड बी हाई। सो पहली चीज हमारे पास क्या होनी चाहिए? डाइलेक्ट्रिक स्ट्रेंथ। डाइलेक्ट्रिक स्ट्रेंथ, ठीक, ये मैं लिखाता भी हूं, गुड इंसुलेटिंग मटेरियल की प्रॉपर्टी मैं आपको लिखाता हूं। ठीक, इट शुड बी हाई। ठीक, ये वैल्यू आपके पास हाई होनी चाहिए, ये एक इंट्यूशन आपका, और वो मैंने आपको बताया भी क्यों होना चाहिए, ताकि ज्यादा वोल्टेज अप्लाई कर सको आप। देन नेक्स्ट कह रहा है कि डेसिपेशन फैक्टर। सो डेसिपेशन फैक्टर बेसिकली दैट इज व्हाट? टेंजेंट क्लासेस, टेंडल। डेसिपेशन फैक्टर एक अच्छे डाइलेक्ट्रिक का क्या होना चाहिए? दैट शुड बी लो, ताकि लो डेसिपेशन हो। सो डेसिपेशन फैक्टर शुड बी लो। थर्ड पैरामीटर है ऑपरेटिंग टेम्परेचर। हमेशा आप चाहोगे कि ऑपरेटिंग टेम्परेचर लिमिट हाई हो ताकि वाइडर टेम्परेचर तक ऑपरेट करा सको। सो ऑपरेटिंग टेम्परेचर लिमिट, ठीक, लेट अस सपोज आपने टेम्परेचर लिमिट कम कर दी, सो आप बहुत कम टेम्परेचर तक डिवाइस को ऑपरेट करा पाएंगे। हम ऐसा नहीं चाहेंगे, वी विल बी वांटिंग दैट कि हाई टेम्परेचर तक मटेरियल बर्दाश्त कर सके, क्योंकि जब भी करंट फ्लो होगी तो करंट के कारण कुछ हीट लॉसेज होंगे, हीट लॉसेज की वजह से टेम्परेचर बढ़ेगा। सो टेम्परेचर ऑपरेटिंग कैपेबिलिटी अगर मटेरियल की ज्यादा होगी तभी उस टेम्परेचर को विदस्टैंड कर पाएगा, अदरवाइज ब्रेकडाउन हो जाएगा। सो इट शुड बी आल्सो हाई। अब इसके हिसाब से आंसर ढूंढ लीजिए, इसके हिसाब से आंसर क्या होगा, हैविंग हाई डाइलेक्ट्रिक स्ट्रेंथ, लो डेसिपेशन फैक्टर एंड हाई ऑपरेटिंग टेम्परेचर। सो ऑप्शन ए इज द राइट चॉइस फॉर दिस क्वेश्चन। इस क्वेश्चन के लिए जो सही चॉइस है वो ऑप्शन ए है। ठीक, नेक्स्ट, व्हिच वन ऑफ द फॉलोइंग स्टेटमेंट इज करेक्ट रिलेटेड टू द लॉन्ग रेंज ऑर्डर इन फेरोमैग्नेट्स। फेरोमैग्नेटिक मटेरियल के लिए आपसे पूछ रहा कि कौन सा ऑप्शन सही है। बड़ा अच्छा क्वेश्चन है, जरा देखिए। अ मैग्नेटिक फील्ड ऑफ अबाउट 1 टेस्ला, Tesla means Weber per meter square. So Weber per meter square is basically flux. So flux means he is talking about B. So question में field लिख रहा है लेकिन वो B की बात कर रहा है। ठीक, अब magnetic field of 1 Tesla can be produced in an annealed iron with an external field of about this a multiplication factor of this. अब आप एक चीज देखिए, किसी मैग्नेटिक मटेरियल के लिए B is what? Mu R mu naught into H ये होता है। ठीक, B is equal to mu into H. This multiplication factor is this and this is your factor applied field in Tesla. H जो है वो एम्पियर पर मीटर में है। So this mu naught H is your external field in Tesla. External field in Tesla. ठीक, this value, अब मल्टीप्लिकेशन फैक्टर क्या है, म्यू आर। सो बेसिकली इस एक्सटर्नल फील्ड में मल्टीप्लिकेशन फैक्टर म्यू आर है। सो म्यू आर आयरन के लिए कितना होगा, ये आपको याद होगा तभी ये क्वेश्चन कर पाओगे। ठीक, आयरन के लिए म्यू आर जो होता है दैट इज इन द रेंज ऑफ 5000 रफली। ठीक, इट इज इन द रेंज ऑफ 5000। ठीक, हालांकि अनिल्ड आयरन लिखा है, अगर हाइड्रोजन में अनिलिंग कर दें तो ये बहुत ज्यादा वैल्यू हो जाती है, इट गोज बियॉन्ड 20,000 या उससे भी ज्यादा चली जाती है। लेकिन फिर उससे कोई भी ऑप्शन मैच नहीं कर रहा है क्योंकि बाकी के ऑप्शन 2000 के साथ हैं जो कि करेक्ट नहीं है। ठीक, सो अनिलिंग करने से वैल्यू बढ़ जाती है और ये बेसिकली जो आयरन की वैल्यू है वो बिना अनिलिंग के है, हालांकि क्वेश्चन में अनिल लिखा है। सो हम बेस्ट पॉसिबल आंसर निकालने की कोशिश करेंगे 5000 के साथ। सो 5000 का मल्टीप्लिकेशन फैक्टर म्यू आर 5000। अब 5000 में कितना मल्टीप्लाई करोगे आप कि 1 टेस्ला आ जाए, कह रहा प्रोड्यूस 1 टेस्ला। सो 5000 में 1 टेस्ला लाने के लिए जो मल्टीप्लिकेशन फैक्टर है हमारा दैट इज 0.0002। सो दिस वे आंसर इज गिवन बाय ऑप्शन ए। ठीक, ऑप्शन ए आंसर हो जाएगा। यहां भी एक चीज देखिए, मैग्नेटिक फील्ड ऑफ 1 टेस्ला एंड ये फैक्टर भी आपका सेम मैग्नेटिक फील्ड शायद प्रोड्यूस करेगा। दिस इज 0. देखिए कुछ तो आप ऐसे ही गलत कर देंगे। 2000 आयरन के लिए मैग्नेटिक परमियाबिलिटी नहीं होगी, मैग्नेटिक परमियाबिलिटी या मल्टीप्लिकेशन फैक्टर इज इन द रेंज ऑफ 5000। सो ये गलत हो गया, 2000 ये गलत हो गया। अब 5000 में अगर आप ये मल्टीप्लाई करेंगे तो 1 टेस्ला नहीं आएगा, सो ये भी गलत होगा। सो करेक्ट आंसर आपके लिए हो जाएगा ए। ये आंसर क्वेश्चन तभी बना सकते हैं जब आपको आइडिया हो कि म्यू आर यानी रिलेटिव परमियाबिलिटी फॉर द आयरन इज इन द रेंज ऑफ 5000, अप्रॉक्सिमेटली 5000 होती है। नेक्स्ट क्वेश्चन की तरफ चलते हैं। द टिपिकल रेंज ऑफ डेसिपेशन फैक्टर ऑफ अ कैपेसिटर। अब आप कहोगे सारे कैपेसिटर के लिए कहां से रट करके रखेंगे, याद होगा डेसिपेशन फैक्टर मैं आपको लिखाता हूं क्लास में, और मैंने कहा था कि रेंज से ही क्वेश्चन करने की कोशिश करिएगा। डेसिपेशन फैक्टर, डेसिपेशन फैक्टर को हम लोग क्या लिखते हैं, टैन डेल्टा। ठीक, टेंजेंट लॉसेस। हमने आपको एक रेंज लिखाई है, टैन डेल्टा इज 0.0001 से 0.001। ठीक, सो 0.001 10 to the power -4 से लेकर के डेसिपेशन फैक्टर दैट शुड बी 10 to the power -3 तक। ठीक, इस रेंज में होना चाहिए। अब एक चीज देखिए, अगर मैं 10 to the इनमें ऑप्शंस को देखूं तो सबसे पहले तो ये कि 0.2 फॉर इलेक्ट्रोलाइटिक कैपेसिटर टू लेस देन 10⁻² फॉर कैपेसिटर्स। जो लोअर लिमिट दे रहा है वो 10⁻² दे रहा है, नहीं गलत है। 10⁻² नहीं बल्कि हम 10⁻⁴ तक जा सकते हैं। सो दिस कैन नॉट बी आंसर। आगे देखिए, जो लोअर लिमिट दे रहा है 10⁻⁻5 दे रहा है, नहीं 10⁻⁻4 की ही रेंज में रहना है, सो ये भी नहीं। 10⁻⁻3 दे रहा है, ये भी नहीं, ठीक। सो बेस्ट आंसर जो होगा इसके लिए वो 0.1 फॉर इलेक्ट्रोलाइटिक कैपेसिटर टू लेस देन 10⁻⁻4। एक्चुअली ये वैल्यू आप देखो तो ज्यादातर कैपेसिटर्स के लिए, डाइलेक्ट्रिक कैपेसिटर्स के लिए ये वैल्यू इस रेंज में होती है, लेकिन हमारा ये लार्जर वैल्यू है। वो इसलिए कि इलेक्ट्रोलाइटिक कैपेसिटर्स में जो डाइलेक्ट्रिक लॉस होता है वो 0.1, 0.2, 0.3, 0.4, 0.5 तक भी चला जाता है डिपेंडिंग अपॉन द फ्रीक्वेंसी रेंज, ठीक है। तो लोअर लिमिट से मैं इस क्वेश्चन को सॉल्व करने की कोशिश किया हूं, और अपर लिमिट हायर लॉसेस जाएंगे, वो डिपेंडिंग अपॉन फ्रीक्वेंसी होता है। तो ये लिमिट उतना ज्यादा आपको दिमाग में नहीं रखना, लेकिन इससे कम लॉस नहीं हो सकता, इतना लॉस तो होगा ही होगा, चाहे जितना अच्छा आप ये बेसिकली पॉलीमर के जब आप यूज करते हो तब इस तरह के लॉसेस मिलते हैं, मिनिमम लॉसेस होते हैं, और इसीलिए हम लोग उसको यूज भी खूब करते हैं। लेकिन लॉसेस बढ़ते रहते हैं विद इंक्रीज इन फ्रीक्वेंसी। आपको याद होगा कि डाइलेक्ट्रिक लॉसेस इंक्रीजेस विद द फ्रीक्वेंसी। सो ये बेसिकली लोअर फ्रीक्वेंसी के लिए रेंज है, अगर फ्रीक्वेंसी बढ़ाओगे तो ये वैल्यू और बढ़ती चली जाएगी। सो दिस ऑप्शन इज एक्सेप्टेबल, बट दीज आर नॉट एक्सेप्टेबल, क्योंकि इतना नीचे नहीं जा सकती और ये काफी ज्यादा है। सो हमारे पास जो बेस्ट ऑप्शन है वो बी है, ठीक है। बाकी थोड़ा सा वेरिएबल क्वेश्चन है, सब्जेक्टिव क्वेश्चन है, कुछ भी हो सकता है, किसी को वैल्यू याद हो तो बहुत अच्छा, हाँ, लेकिन मैं इसमें जो आंसर दूंगा मेरे हिसाब से इसका आंसर बी होना चाहिए, ठीक। नेक्स्ट आते हैं, द पॉइजन रेशियो फॉर मोस्ट ऑफ द मेटल्स लाइज, प्योरली रटना पड़ेगा। तो आजकल एक दो क्वेश्चन मैकेनिकल के मटेरियल साइंस से जरूर पूछे जा रहे हैं, पता नहीं क्यों, जबकि इलेक्ट्रिकल वालों, ईसी वालों से मैकेनिकल मटेरियल की बात करना जस्टिफाइड नहीं, लेकिन फिर भी पूछते हैं। जैसे इसमें पॉइजन रेशियो मोस्ट ऑफ द मेटल्स के लिए पूछा है। सो मेटल्स के लिए जो पॉइजन रेशियो होता है वो 1/4 से 1/3, दैट इज रफली अराउंड 0.25, 0.35। सो डी ऑप्शन इज द करेक्ट आंसर। इसमें जो आएगा मेटल्स के लिए पॉइजन रेशियो इज इन द रेंज ऑफ 0.25 टू 0.35। ये आपको याद होगा तो कर लोगे, नहीं याद होगा तो नहीं कर पाओगे। दीज वर द ओनली क्वेश्चंस फ्रॉम द मटेरियल साइंस। सो मटेरियल साइंस से काफी कम क्वेश्चन पूछे गए, जो पूछे गए हैं वो मैंने आपके साथ कर दिया। एक दो करने लायक थे, एक दो नहीं करने लायक थे। थैंक यू।
Yeah, I will do the questions of communication systems along with Naveen sir. Okay. So if you see this question number 46, this is related to amplitude modulation. Here the power transmitted by SSB transmitter is 20 kilowatt is given. Okay. So the power of SSB is given as 20 kilowatt. Okay. And it is required to be replaced by standard AM transmission, means this SSB has to be replaced by AM having modulation index of 0.4. Okay, having modulation index of 0.4 means mu is equals 0.4. Okay, and same power means the AM power, okay, is same as SSB power, means SSB has to be replaced by AM, okay, where AM has to deliver the same power as SSB with mu is equals 0.4. Okay, it is given you just to make you to get confused, that is it. Okay, we do not find any use of this, okay, in solving this question. Then what is the transmission efficiency of that AM, we have to find out. The transmission efficiency is also called as power efficiency, that is mu square by 2 plus mu square. Okay, so mu is given, and if you substitute mu 0.4, it comes to be 7.4% you will get. Okay, so option C is going to be correct. And if you see question number 47, here an angle modulated signal is given and you have to find the instantaneous frequency, we have to find out. The angle modulated signal, it is a very simple question, okay, we done in the regular classroom. AC cos theta I of t, you can see like this. Then the instantaneous frequency Fi is equals to 1 by 2 pi differentiation of theta I of t. Okay, we use this formula so many times in the classroom. Okay, and it will be equals to 1 by 2 pi times 2. Okay, so differentiation of theta I of t, here this will be, this is, yeah, so this is theta I of t. Okay, now this is 1 by 2 pi times 2, differentiation of theta I of t. What is the differentiation of this? Will be 200 pi, this is, so this will be equals to 100 hertz. So option B will be correct for this. And if you see this question, question number 48, so this is about relating the modulation index of FM and PM, phase modulation. Okay, so if you see the beta of FM, here the measure signal, it is given amplitude of AM and frequency of 5 kHz. The message signal having single frequency means you can see as the default of sinusoidal message signal. Then beta of FM will be KF AM by FM. Okay, so KF is given how much here? 1.5 kilohertz per volt. This is kilohertz per volt, and amplitude, the message amplitude is given as 5. Okay, and frequency is given 5 kilohertz. And from this you come to know this is 1.5 you will get. And if you see beta of PM, so beta of PM is Kp AM, and Kp is given 1.5 radians per volt. Okay, and amplitude is given as 5. Okay, now you can see beta of PM is equals to 1.5 times 2. So yeah, this is 5 times 2, I can say this is, yes, this is 5 times 2, this 1.5 is actually beta of FM only. Okay, so beta of PM is equals to 5 times to beta of FM. Okay, beta of PM, the modulation index of PM is 5 times to modulation index of FM. So option D is going to be correct. And if you see question number 49, this question was not formed properly, okay, because the terminology, the data which is given in the question, and the options which are mentioned nowhere matching to each other. Okay, but maybe the examiner is trying to ask you this, maybe we can, I will proceed in this way. Okay, so one possibility is here, what is the relationship between the percentage efficiency saving when the carrier wave and one of the sideband is suppressed in an AM. So in AM, okay, carrier and one of the sideband is suppressed. So if carrier and one of the sideband is suppressed, okay, then this eta of AM, what you see, okay, I will see this eta of AM as what is the power of the resultant modulated signal only. I will see in this way. Then only, okay, we can solve this question. Otherwise, the question can't be solved. Okay, the options are not matching like. Okay, yes, in AM, if carrier and one of the sidebands are suppressed, okay, then what is the power of the resultant AM? Okay, if carrier and one of the sideband is suppressed, then we left with only one sideband. And what is the power of that sideband? Power of one sideband is PC mu square by 4. Okay, and I will see this eta of DSB as, okay, this is the power of DSB. So this is the power of AM after, okay, the carrier and one of the sidebands is suppressed. Okay, then what is the power of the resultant AM? This is the power of the resultant AM after this carrier and one of the sidebands is suppressed. means only one sideband we left with, that is PC mu square by 4. Okay. Then what is the power of DSBSC? It is having two sidebands in it, that is PC mu square by 2, okay, the total sideband power. Then you will come to know this eta of DSB is equals to, this is, okay, 2 times 2 eta of AM. Okay. So, just based on the given options I solve this question, okay, because as I said, okay, the data which is given in the question is okay, we can't relate with the notations what you mentioned, because eta generally we see as power efficiency, but if you take this eta as power efficiency and if you proceed to solve this question, the options are not matching. Okay. So, here just to get the answer to be matched with one of the options, I am proceeding like this, means after carrier and one of the sideband is suppressed, what is the power of AM this is, because only one sideband we left with, and what is the power of DSBSC, okay, that is total sideband power PC mu square by 2, then this is how you can relate, then option D seems to be correct for me. Okay. But actually speaking, this is something incorrect, I can say the data what is given and the options what given are not matching. Okay. Then few questions will be taken by my colleague Naveen sir, okay, he will take care. Thank you, Naresh sir. So, you can see the question number 50. So, in the question number 50 he given S of t. So, S of t is given as 5 cos of 2000 pi into t, and the number of bits n is equal to 10. The given system is the PCM, pulse code modulation system. Asking STNR, signal to quantization noise ratio. If you signal to quantization noise ratio, that is equal to 3 by 2. So, value is equal to that of 2 to the power of 2n. So, 3 by 2 into 2 to the power of 2 into 10. So, if you solve this one, we will get the value is equal to 1.57 into 10 to the power of 6, and that is the C. Option C is the correct answer. Okay. So, next question 51, an FM audio signal with a single tone modulation having a frequency deviation of 25 kilohertz and a bandwidth of 75 kilohertz. What is the frequency of the modulating signal using Carson's rule? So, we know about the Carson's rule, the transmission bandwidth Bt is equal to 2 into delta f plus Fm, or we know 2 into beta plus 1 into Fm also. In the given question delta f, the frequency deviation is given, that is 25 kilohertz, and if you see the another question, that is bandwidth is given. So, bandwidth Bt is equal to 75 kilohertz, and he is asking to find out what is the modulating signal frequency. So, Fm is equal to how much? If you substitute this 75 kilohertz 2 into 25 kilohertz plus Fm, so we get 75 kilohertz, that into 50 kilohertz plus 2 Fm, and multiplying with this. So, the 2 Fm is equal to 25 kilohertz, then Fm is 12.5 kilohertz is the value we are having. So, Fm value is equal to 12.5 kilohertz, which is option A is the correct answer. Okay. So, coming to the next question, that is 52. An audio signal S of t is normalized whose Fourier transform S of f is shown in the figure. This is the Fourier transform given, S of f. So that mod S of t should be less than or equal to 1. The signal is to be transmitted using Fm with a frequency deviation constant Kf, 90 kilohertz per volt. So, what is the bandwidth required for transmission of the FM audio signal? So, once again is asking about the bandwidth. So, given mod of S of t should be less than 1, and from the sketch we get FM, that is FM maxima is equal to 20 kilohertz, frequency is obtained. So, given question Kf is given already. So, Kf is equal to 90 kilohertz per volt. So, from this we need to find out our delta f maxima. So, delta f maxima is equal to Kf into mod of S of t. So, mod of S of t, so maxima, that Kf is equal to 90 kilohertz per volt into S of t maxima is equal to 1. volt, and that is equal to 90 kilohertz we are having. So, the next one is given as the bandwidth. See, transmission, asking the bandwidth required for the transmission of the FM signal. The transmission bandwidth BT is equal to 2 into, so delta F maxima plus FM max. So, then we can substitute the value 2 into delta F maxima, that is equal to 90 kilohertz, plus FM max. If you see FM max, that is equal to 20 kilohertz. So, the total value is equal to, answer is, so 90 plus 20, that is equal to 2 into, so 110 kilohertz, that is 220 kilohertz is the bandwidth we are having. So, option C is the correct answer. So, the remaining questions will deal with the Naresh Reddy sir. Okay. Okay, I will go with the remaining questions. So, if you see this question number 53, okay. So, this is somewhat different question. Generally, in most of the standard textbooks, you don't find this question. Okay. So, this is given Kennedy textbook. It was given. Okay. Generally, in other textbooks, okay, you don't find such discussion. Okay. Fine. Okay. How to proceed to this is, here a collector modulated class C power amplifier is giving an amplitude modulated signal of 220 watts. Okay. So, here for generation of AM signal, here the collector modulated class C power amplifier is used, okay, for generation of AM signal. Then what is the AM power? It is 220 watts. Okay. Okay. So, AM power, average power at the output. Okay. Average power means yes. Yeah, let me repeat this question. So, if you see this question number 53, okay. So, here generally you do not find this question in the most of the textbooks, okay, in the standard textbooks you do not find this question, okay. It is this model of question is given only in the Kennedy textbook, okay. Fine, okay. Let us proceed with this. Here for generation of AM signal, the collector modulated class C power amplifier is used. This is one of the ways of AM generation, okay. So, and it is generating AM signal with 220 watts average power at the output, okay. Average power of average power means that you can see as the total power of AM signal only, okay, and that is 220 watts. And while operating with a collector circuit efficiency of 40%. So, for this class C power amplifier, the collector circuit efficiency is given 40%. We use this later, okay, just keep this aside. And what is the power to be supplied by modulating amplifier when the modulation index is 0.4? The modulation index mu is given 0.4. Then from this you can find PC, PT is PC times 2 1 plus mu square by 2. So, PC you will get is 203.7 watts. Then you can find this sideband power here, okay. The sideband power is equals to PT minus PC. So, PT minus PC is equals to, this is 220 minus 203.7, okay. So, this is, it comes to be, if you do it, then you come to know this is 16.29 watts you will get. So, if you find PC, so if you take 2 decimal places, after 2 decimal places if you take, then you will come to know 16.29 watts. This is the sideband power, okay. Actually speaking, so this sideband power, this is the power which is supplied by the modulating amplifier, okay, modulating amplifier. Because if you give the carrier signal as the input, okay, carrier signal as the input, what is the carrier power? PC, okay, and this is the carrier signal we give as the input, okay, and whose power is PC, and the AM signal is getting generated, okay, and AM power is 220 watts. Okay. So, then that sideband power, the remaining sideband power is actually given by the modulating amplifier only. So, whatever the power given by modulating amplifier, that power will be converted to sideband power actually, that power will be converted to sideband power. Okay. So, this is the power which is generated by the modulating amplifier. Okay. Then actually, but here, here the collector circuit efficiency of 40% is given. Okay. By considering this collector circuit efficiency of 40%, then I can say the DC power, okay, supplied by, it is actually the total power that is supplied by modulating amplifier 16.29 watts. This is the total power supplied by modulating amplifier, but we have to find out the DC power that is supplied by modulating amplifier, we have to find out. Okay. Yes, by knowing this, okay, collector circuit efficiency 40%, okay, by using that, the DC power supplied by modulating amplifier will be equals to, this is 16.29 by, okay, collector circuit efficiency is how much, 40%, this is 0.4. Okay. So, this will give you the DC power supplied by the modulating amplifier, and it comes to be 40.7 watts you will get. Okay. So, this is option B is going to be correct. Okay. Yes. If you see the next question. So, here we have to find the normalized power of AM signal. Normalized power means the resistance value you have to take 1 ohm. So, if you take the standard AM signal, that is AC times 2 1 plus KAMT cos 2 pi FCT. Okay. So, this you can write as AC cos 2 pi FCT plus AC KAMT cos 2 pi FCT. Okay. Then if you see the power of this, okay, AC cos, the power will be AC square by 2 plus, and this is AC square and Ka square, the power of MT you can write as M square T, and cos will be 1 by 2. This is okay. But if you see the given options, okay, in the given options nowhere we see Ka here, Ka you do not see in the options, then we take the default Ka, actually the default Ka we take as 1 by AC. If Ka is not given, we take default Ka is 1 by AC, but if you substitute Ka is 1 by AC in this, the options are not matching, then okay, what you can understand is here he taken the Ka 1 he taken here. So, if you take Ka equals to 1, then power you will get as, okay, to match with the given options, okay, I am taking Ka is equals to 1 because there is no other way to match with the given options, okay, plus this is AC square Ka square, Ka square, this we taken 1 now, this is AC square M square T by 2. Okay. So, option A is correct here. Okay. Yes. And if you see this question number 55, this is related to AM. Okay. The AM power is given by 125 kilowatt. Okay. When this is modulated by, okay, a sine wave, okay, with the depth of 70%. So, here this is the AM power due to first message signal, you can see this as 125 kilowatt and mu 1, that is 0.7. Okay. And this is delivering 144.5 kilowatt when a second sinusoidal audio wave is also modulates it simultaneously. Means when the carrier is simultaneously modulated by second message signal, the AM power is increased to 144.5 kilowatt. So, this is I can see as the total power 144.5 kilowatt. So, this total power, it is due to carrier is simultaneously modulated by both first and second message signals, you can understand. Then what is the depth of modulation for the second message signal, we have to find out. Okay. So, the mu 2 we have to find out. Okay. And here what is the corresponding modulation index is mu t here. Okay. Then if you see one of the easiest way is Pt is equals to Pc into 1 plus mu t square by 2, this is, and this is Pc into 1 plus mu 1 square plus mu t square by 2 you can write. So this PT1 you can see this is PC into 1 plus mu 1 square by 2. Then I can write this total power is equals to PC into 1 plus mu 1 square by 2 plus PC mu 2 square by 2. Okay. Then PT is equals to 144.5 kilowatt. This is, and PC into 1 plus mu 1 square by 2 directly you can substitute. This is 125 kilowatt plus PC mu 2 square by 2. So from this you can get PC also here. So here from this you can get PC from this. So what that PC you will get is, okay, yes, this is PC is equals to 125 by 1.245 you will get. This is, just substitute here, the mu 1 is 0.7, just substitute here, then you will get PC is equals this much. So by substituting this PC value here, okay, then you will come to know mu 2 square is equals to 0.388 you will get. Okay. Then mu 2 is equals to under root of 0.388. This is what you will get. So this is somewhat ambiguity in the options. Okay. So I will go with okay, if you consider only one decimal place, okay, then that is under root of 0.3 I will take. But I don't know if the examiner will round off this to 0.4, okay, then that will be under root of 0.4. Okay, option A is going to be correct. So we have to wait for the key. Okay, so I'm taking this as, I'm taking only one decimal place, then I'm writing this as under root of 0.3 I'm writing, but okay, you can go with option A also. Let's wait for the key. Okay, yes. And this question number 56 here, it is about delta modulation. Here you have to find signal to quantization noise ratio, but here the options given are not matching actually, because the signal to quantization noise ratio of delta modulation, that is 3 by 8 pi square, it is Fs cube by, this is Fm square into F capital M. This is the signal to quantization noise power ratio of delta modulation, where F capital M is the cutoff frequency of the low pass filter, but if the cutoff frequency of low pass filter not given, we take this as same as message frequency only. F capital M is F small m, then signal to quantization noise power ratio 3 by 8 pi square, this is Fs by Fm cube you will get. Okay. So the sampling frequency not given in the question, so I am taking the default of the sampling rate is, Nyquist rate I am taking 2 Fm. So if you substitute here, this is 3 by 8 pi square, this is 3 by 8 pi square. So if you substitute Fs is 2 Fm, if you substitute Fm cancel 2 cube is equal to 8 will be cancelled, that is 3 by pi square. So by simplifying this, this is 0.303 is what we are getting, okay, but options are not matching. Okay, so this is some mistake, because even the data is not sufficient to solve this question. The sampling frequency should be mentioned in the question, that was not mentioned, but even if you take the default of Nyquist rate, the options are not matching. Okay, fine. And if you see here, the quantization levels are increased from 4 to 64. So L is increased from 4 to 64. Then what about number of bits per sample? L is equals to power n. Okay, then I can say this is 2 to 6 I can say. N is increased from 2 to 6. Okay, then the transmission of the PCM signal, okay, the bandwidth required for the transmission of PCM signal increases by a factor of. So the bandwidth of, okay, PCM is proportional to RB I can say. Okay, so the bandwidth is proportional to NFS, RB is NFS. The bandwidth is proportional to N I can say. So this is bandwidth 1 by bandwidth 2 if you see, as N is increased from 2 to 6. Okay, so this is N1 by N2 I am writing. Okay, so this is 2 by 6, so that is 1 by 3. Okay, so the bandwidth will be okay, okay, the transmission bandwidth of PCM is increased by a factor of 1 by 3 times. Actually, as n increases from 2 to 6, the bandwidth requirement is increased by, I can say, 3 times, I can say, actually speaking, okay, because the bandwidth is proportional to n here, okay. As n is increasing from 2 to 3 means, okay, the n is getting tripled, okay, 2 to 6 means, okay, 2 times to 3 is 6. So, n is getting tripled means the bandwidth requirement also is getting tripled, actually speaking, but based on the given options I can say that is 1 by 3, I can say bandwidth 1 by bandwidth 2, okay, 1 by 3. So, option A will be correct. Now, if you see assertion reason question, okay, this is question number 87. Here for generation of VSB, the frequency discrimination method is used. Okay, actually for frequency discrimination method is used for SSB generation, not for VSB generation. So, this one is false, okay, and statement 2 is one of the sidebands is partially suppressed, okay, fine, and a vestige of the other sideband is transmitted to compensate for the suppression. Yes, this is true in regards of VSB. Okay, so 1 is false and 2 is true, okay, then option D is going to be correct. And if you see question number 90, okay, so here the sampling and quantization operations, the errors are introduced into digital signal. Yes, of course, these errors are reversible and it is possible to produce the exact replica of the original analog signal from the digital representation. That is incorrect actually, because whatever the errors introduced in the quantization process, those errors can't be reversed and you cannot get the original message signal back, you cannot. Okay, this is statement 1 is false. Statement 2, the use of digital communication offers flexibility and compatibility in that the adoption of a common digital format makes it possible for a transmission system to sustain many different sources of information in a flexible manner. Yes, of course, in digital transmission you will see so much of flexibility in transmission process, that is definitely the adaptability and flexibility, of course you will see in digital transmission. Yes, statement 2 is going to be correct. So, 1 is false and second 2 is true. So, again option D is going to be correct for this. Okay, yeah, fine, thank you.
Hello students, this is Sagar. I am going to discuss computer organization and architecture questions. Okay. First question in the computer organization subject is on the screen. Okay. So in this question they given the different instructions present in the program and number of cycles required for each instruction given. We need to find out the average CPI. Okay, how many cycles are required per each instruction, that we need to calculate, right. So average CPI is equal to number of cycles per program divided by number of instructions in the program. How many cycles are required in the program upon number of instructions in the program, that is equal to CPI, average CPI. Okay. So here 38 instructions, ALU instructions present in the program. each ALU instruction consume 1 cycle, plus, and 15 instructions are load and store, each load and store consumes 3 cycles, plus 42 instructions are branch instructions, each branch instruction consumes 4 cycles, okay, plus 5 instructions are other instructions, each other instruction consumes 5 cycles. These are the total number of cycles required in the program. Upon number of instructions in the program is 38 plus 15 plus 42 plus 5. Okay. So, perform the computation. Okay. After compute the above expression, we got the value, that is 2.76. So, average CPI is 2.76 cycles. According to the options, the correct answer is A. A is the right answer, 2.76. Okay. This is a direct question from your running notes. I already explained this kind of the questions in your classroom program as well as the online program. So, in your class notes, running notes, you have this question, right? Next question in the computer organization subject is on the screen. You just see that question. This is also direct question from your running notes. Okay. What is the number of bits in main memory address? We need to find out the address size of main memory with the following specification. What is given here? Size of the main memory is 4 kilo blocks, size of the cache is 128 blocks, and block size is 16 words. Okay. So, here number of main memory blocks, number of blocks in main memory given is 4K. Next, number of lines in cache memory, number of main memory blocks 4K, number of lines in cache memory 128. Okay. Next, block size given in the question is 16 words. Okay. Assume that system uses set associative mapping of 4 blocks per set. They given 4-way set associative. Okay. Actually, this 4-way set associative information is a extra information. We don't want this information to solve the question. Okay. Because question is expecting only the main memory address size. So, we should know what is the main memory size. When you know the main memory size, automatically address is depends on the capacity of main memory. So, here main memory size is equal to number of blocks in main memory into block size. Okay. So, here number of blocks are 4 kilo blocks into block size is 16 words, that becomes 2 power 12 into 2 power 4 words, that is equal to 2 power 16 words. That means 2 power 16 cells are there with a cell size of 1 word. Therefore, memory address size, main memory address is equal to 2 to the power log 2 power 16 base 2, number of cells base 2, this is equal to 16 bit. So, number of address bits required to refer the main memory equal to 16. So, according to the options, when we see the option, correct answer is D. D is the answer, 16. 16 bit address is required to refer the main memory. Okay, students. Okay, this is the direct question from your class notes. Similar questions I covered in the class. Okay, only data change is present. Right. Next question is on the screen. You just see the question once. Here 4 main memory frames are given. Number of frames in the main memory 4. These are the page references. When main memory status is not given, initially main memory is empty, right? Now CPU accessing the data in this order using the LRU, least recently used policy, LRU policy, right? How many page faults are occurred in the system? This is the question. Again, this kind of the question is also covered in the class notes. You know that. Okay. So apply the LRU policy and find out the number of miss operation. Miss operation is nothing but a page fault. Okay. All right. So first thing, in LRU policy, what we are maintaining is whichever the page is referred by the CPU, all those recent references are keeping on top. When recent references are in the top, automatically bottom elements are least recent elements. So least recent elements are eliminated when the memory is full. Alright? Okay. So first here 4. 4 is not in the main memory, miss. So that transfer it from secondary memory to main memory. Next 7. 7 is not in the main memory, miss. So transfer it from secondary to main memory. Recent reference is keeping on top. Next 5, miss. So keep it on top. Transfer it from secondary memory to main memory. Keep it on top. Okay. Right. 7, hit. Recent references required on top. So 7, 5, 4. Like this order changed in the main memory. Next 6, miss. So that keep the 6 on top. 6, 7, 5, 4. This is the order. Alright. Next 7, hit. When it is hit, keep 7 on top. 7, 6, 5, 4. This is the order. Order changed like this. Next 10. 10 is miss. Keep it on top. 10, 7, 6, 5. 4 is automatically eliminated. So bottom elements are least recently used elements. They are eliminated. Okay. So 4 not in the memory. Miss. Keep it on top. 4, 10, 7, 6. So 5 is automatically eliminated. Next 8. 8 is miss. So 8, 4, 10, 7. 6 is automatically eliminated. All recent references are on top. Next 5, miss. So 5, 8, 4, 10. 7 is automatically eliminated. Next 8, hit. 8, 5, 4, 10. So order changed. Next 6, miss. So 6, 8, 5, 4. 10 is eliminated. Next 8, hit. Order is 8, 6, 5, 4. Next 11, miss. Order is 11, 8, 6, 5. 4 is automatically eliminated. Next 4, miss. 4, 11, 8, 6. 5 is automatically eliminated. Next 9, miss. So 9, 4, 11, 8. 6 is automatically eliminated. Next 5, miss. So 5, 9, 4, 11. 8 is automatically eliminated because of least recent element. Next 9, hit. 9, 5, 4, 11. Right, order changed. Next 6, miss. So 6, 9, 5, 4. 11 is automatically eliminated. Next 9, hit. Order changed. 9, 6, 5, 4. Next 12, miss. 12, 9, 6, 5. 4 is automatically eliminated. Then 4, miss. So 4, 12, 9, 6. 5 is eliminated. Next 7, miss. 7, 4, 12, 9. 6 is eliminated. Next 5, miss. 5, 7, 4, 12. 9 is eliminated. Then 7, hit. So 7, 5, 4, 12. Order changed. So this is the way to access the pages from secondary memory to main memory by using the LRU policy. Now question is, how many miss operations are occurred? Miss operation is nothing but a page fault. Just count the miss operations here. Okay. So count the miss operations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. 18 page faults occurred. So total number of misses are 18. 18 misses present in the total accessing sequence. Miss operation is nothing but a page fault. Now go to the options. When I refer the given options, 18, C is matching. So correct answer is C. Hope you understand, dear students. Okay, all right. So next question is on the screen. You just see the question. Which one of the following is correct with respect to the short-term scheduling? You know, in the operating system, we have 3 kinds of schedulers. Okay, long-term scheduler, short-term scheduler, and mid-term scheduler. Okay, I already explained the responsibilities of all the 3 types of the schedulers. Okay, in the class notes. So directly by taking the help of that concept, we are going to select the right answer. Short-term scheduler is responsible to schedule the ready state processes into running state. When a main memory processes are scheduled to CPU to execute. Okay, that is the responsibility of short-term scheduler. According to this concept, we are going to select the right answer. Okay, the right answer is A. The decision as to which available process will be executed by the processor. So A is the right answer. So ready state processes are scheduled to running state. That is the responsibility of short-term scheduler. Okay, students. So A is the right answer. Next question. You just see the next question that is on the screen. Which one of the following statement is correct with respect to the bounded buffer in shared memory systems? Bounded buffer. Actually, bounded buffer, like a producer and consumer, it's a producer and consumer related concept. Okay, this is the best example, okay, to access the concurrent accesses of the shared data. Okay, bounded buffer or producer consumer problem is the best example for concurrent accesses of a shared data. Okay, here bounded buffer is used by the multiple producers as well as the multiple consumers. Okay, multiple producers are keeping the information inside the buffer and multiple consumers are retrieving the information from the buffer. Okay, same buffer is used by multiple producers and multiple consumers. Okay, that is the bounded buffer. But here producer write the information or write the data into the buffer and consumer read the data from the buffer. But in this we should follow one thing. Producer will be blocked when the buffer is full. Consumer will be blocked when the buffer is empty. When the buffer is full, no producer is writing the data into the buffer. When the buffer is empty, no consumer is reading the data from the buffer. So that producer will be blocked when the buffer is full. Consumer will be blocked when the buffer is empty. Okay, so this is the concept of the bounded buffer. Okay, so with respect to this concept, when we are going to select the answer, right, the correct answer is B. The consumer must wait if buffer is empty and producer must wait if the buffer is full. So B is the suitable answer in this question. Okay, according to the question, suitable answer is B. So bounded buffer is a producer consumer related concept. So here this concept is the best example of the shared resources. Okay, concurrent accesses of the shared resources. Okay, so answer is B. Alright, next question is on the screen. You just read the question once. Which of the following is relevant to the non-preemptive kernels? Okay, as you know that non-preemptive scheduling. Non-preemptive scheduling means when the process is in the CPU, okay, no other process will be allowed into the CPU until the current process execution is completed. That is the meaning of non-preemption. Non-preemption means one after another. So once the process is scheduled to CPU, complete that process. Later we can access the new processes. That is non-preemption. Okay. So one after another is nothing but a non-preemptive scheduling. So according to this non-preemptive scheduling concept, select the suitable answer, right? So when I select the suitable answer, C is best suit. You just see this, kernel does not allow a process running in the kernel mode to be preempted. Okay, preemption is nothing but a suspension. Okay, non-preemption means one after another. Okay, so here a kernel mode process will run until it exits kernel mode blocks, yields control of the CPU. That's it. So non-preemptive scheduling means execute the process one after another. So according to that concept, best suitable option in the given options are C. C is the right answer. Hope you know this concept, because in the classroom we covered so many questions related to the scheduling policies. So in that we used sometimes non-preemptive scheduling, sometimes preemptive scheduling. So with that concept directly you can answer this question. So answer is C. Okay students, next question is on the screen. Please read the question. Which one of the following is used to perform transfer of data between two memory mapped devices without intervention of the CPU to the main memory? That means what? Which of the following mechanism is suitable to transfer the data from IO device to main memory without involvement of CPU? Okay, so this is a direct answer, that is called as direct memory access, DMA. DMA is the IO transfer mode. So DMA is a module which is responsible to transfer the data from IO to main memory without involvement of a CPU. So this is a straightforward question. This concept already known to you. According to COA subject, you know this concept. Also microprocessor subject point of view, you know this concept. DMA. In this mode, bulk amount of data will be transferred from IO to main memory without involvement of a CPU. Okay, so based on this concept, correct answer is DMA, C. Right answer is C. DMA is the concept used to transfer the data from IO to main memory without involvement of a CPU. Clear now? Right. Next question is on the screen. You just read the question once. Which one of the following threats is used to facilitate the designer of a program or software system which might leave a hole in the software that only he or she is capable of using? This is a general question actually. Okay, latest application oriented question, right? So in this question we need to identify the which of the following mechanism is inserting the hole or leaving the space in the program. Later that space will be used by the user to access any system without knowing the existing security policies, protection policies. Okay, so according to given options, the correct option is trapdoor. Okay, trapdoor is a kind of inserting the security entry, inserting some space in the program or software. Okay, later that space is used by any user to access any system without knowing the normal protection or normal security policies. Okay, so here trapdoor is the answer which allows the space in the program. Okay, therefore users are accessing the other systems, okay, any system by using that entry point. Okay, so right answer is B. Clear? Okay. Next question is on the screen. You just see this. Windows keeps much of its configuration information in the internal database is called as. Okay, this is also the generalized question. Okay, so by using the general information, Windows, installation of Windows, we are going to answer this question. So normally when we are going to install the Windows, the total configuration information is stored in the window registry. Okay, so window registry is the database where the total settings or configurations are stored in the system. Okay, so according to the given options, when the registry is not mentioned, we are going to take the suitable option. Okay, the suitable option is hives. hives is the top layer of the registry, so that in the hives the total configuration information is available. So by using that information we can able to install the new software or anything is possible. So that correct answer is D. D is the right answer. Okay, actually registry, window registry is the database, but here options window registry is not given. That's what we are taking the next level of the option, that is hives, right? Okay, next question in the computer organization subject present in the exam paper is on the screen. You just read it. Which one of the following is a drawback? We need to identify the disadvantage of programmed IO and interrupt driven IO. Okay, we are going to identify the disadvantage, drawback. Okay, so when we see the programmed IO and interrupt driven IO, okay, actually CPU is responsible to transfer the data from IO to any other devices, okay, except the DMA. In the DMA, CPU is not involved in the data transfer. Okay, so IO to main memory or main memory to IO, data transmission is controlled by DMA. And remaining two modes, programmed IO mode and interrupt driven IO mode, in these two modes compulsory CPU takes the responsibility. Okay, in the programmed IO completely CPU will be blocked until IO data transmission is completed. Okay, so CPU utilization is very poor in the programmed IO, whereas in interrupt driven IO CPU utilizes CPU time for other program until interrupt occurred. Whenever interrupt is occurred, immediately CPU servicing the interrupt request. Interrupt subprogram execution means used to transfer the data from IO to other devices. Okay, so that in the programmed IO as well as the interrupt driven IO, CPU is compulsory involved to transfer the data. Therefore, CPU executing the IO related instructions to complete the data communication except the DMA. Okay, so we need to find out the drawback. According to the drawback, when we are looking at the options, the suitable option is A. A is the right answer. The processor is tied up in the managing of IO. Yes, it's true. CPU is responsible to transfer the data either in the programmed IO as well as in the interrupt driven IO. So compulsory CPU time is wasted. So correct answer is A. A is the suitable answer. Okay students, alright. This concept is covered in the computer organization, also in the microprocessor subject. Okay, so there are the common concepts present in the COA and microprocessor. That's what you can easily answer all the questions related to the microprocessor concepts and COA concepts, right? And last question in the computer organization subject is on the screen, you just watch it. Which one of the following methods requires saving the value of CPU registers from the thread being switched out and restoring the new threads being scheduled? You know, one process is swap out, another process is swapping. Whenever we are doing the preemption, compulsory we need to save the context of the process. When we are saving the context of the entire process, okay, compulsory we are using the concept context switching. Simply one process, when you are suspending in the middle, its status will be saved in the space. Okay, so that is called as the context switching between kernel level threads. Okay, this is the direct conceptual question. So answer is A. Next. One more question is there, actually pipelining question. This pipelining question, okay, I also covered in the COA syllabus, and also it is present in the advanced electronics, that is VLSI design. Okay, so just see that question also. This is a reason and assertion question. Pipeline processing cycles are overlapped with the computer instruction cycle in execution of the performance improvement. Yes, that statement is 100% true. Pipelining allows overlapping execution. Overlapping execution means CPU cycles, instruction cycle allows the instruction fetch, decoding, execution, write back. All these stages are executed in a overlapping order. Due to this overlapping order execution time of the entire program is decreased, performance is increased. So that this statement is true. And second statement given, pipelining is a technique of decomposing a sequential process into sub-operations, and each sub-operation being executed in a special dedicated segments and operated them in a concurrent manner. So this is the total meaning of pipelining. Pipelining allows decomposition technique. Divide the problem statement into independent sub-problems and assign them to independent hardware. Later connect them in a common clock, connect them to a common clock. Therefore, all the independent hardware units are running in parallel. So due to parallel execution, automatically execution time decreases, performance increases. So that is the meaning of the pipelining. This statement is also true. According to the reason and assertion, okay, these both the statements are true statements, and this is the second statement is the correct explanation of the first statement. Okay, so according to the reason and assertion, right answer is A. Both the statements are individually true, and second statement is the correct explanation of the first statement. Okay students, yeah, these are the questions related to the computer organization subject. Okay students, thank you all. Okay, I wish you all good luck. Bye bye, take care.
Hello dear students, very good evening. I am Vijay Kumar. We will be discussing about the microprocessor related questions which were given in ESE 2023. So here let us go with the first question, that is question number 25. So this is a program, there were 7 questions which were given, but among all these questions, all of these questions have discussed same type of questions in the classroom also. So whoever has attended the class or attended the course with MEDIC, definitely you would have been it would have been very simple for you to solve all these questions, right. Let us go with the first question. The following sequence of instructions are executed by 8085 microprocessor. So 3 instructions are there. So what is the question? The content of the stack pointer and the HL register pair on completion of execution of these instructions would be. So very simple, look at the program, it starts at 1000H. So this is where the program starts at, and you know that each instruction length. So here the first one is 3 byte instruction, and this is also a 3 byte instruction, and this one is a 1 byte instruction. Okay, fine. So let us discuss about what is the meaning of each one. LXI SP comma 27FF, it means load immediate this 16-bit value into stack pointer. So therefore stack pointer register contains the value 27FF. Okay, fine. So what is stack? Stack is used to store the temp data and also value of the program counter when some subroutines are executed. Fine. So here if you observe, the next instruction is call 1006. See, call instruction is to call a subroutine program from the main program. So this is the main program, from here it has to go to the subroutine program. So for example, if you understand this sequence of execution, it is very easy to solve the question. See, for example, call is present at 1003 address 1003H. So this is where the call instruction is present. So call, say call, yeah, let me just write like this. Yeah, so call 1006. So this is where the instruction is there, and logically is given like this. So there are 2 simple steps when call is executed. See, if I observe carefully, so from here the program control should go to some subroutine whose address is 1006. So what is the instruction here? It is pop H. So 2 things happen when call is executed, very simple, understand carefully. So the next instruction address is, this is 1006, but the question is given logically, okay. So from main program it has to go to some subroutine program. So what is the answer? Very simple. So look at the first step. The first step is when call is executed, number 1, what is number 1? The next instruction to the call, whatever it is, this value is automatically pushed on to stack memory. So if you look at carefully, so this is the stack memory, let us say, so the stack pointer where it is present, 27FF, so 27FF, so it is stack pointer value, already some temporary data is there, so do not worry what is the temporary data, and this one is 27FE and this address is 27FD. So these all are hexadecimal values. So when call is executed, the next address is pushed on to stack. So this value means the program counter value is automatically pushed on to stack. So first one, this is SP minus 1 address, SP minus 1 address, so higher byte is copied here, and SP minus 2, the next byte will be copied to the stack location 06H. So this is the current value of stack pointer after execution of the call instruction. So that is first step. Second step is the program control is automatically transferred to the stack subroutine address whichever it is. So it goes to this location. So therefore the continuation of program will start from this pop H. So the next instruction is pop H. What is pop H? The content whichever is there at top of the stack memory, it is automatically loaded into the corresponding register pair. Therefore the current value of SP, if you observe carefully, this is present at the location 27FD. So this value should be brought into HL pair. So actually this was actually program counter value. So now the same value from top of stack is popped, means loaded into HL register pair. Therefore this is the current value of SP after a call instruction. So these 2 bytes are brought into H and L. So therefore what happens to this one? 06 is brought into L and SP becomes SP plus 1 and the next byte is brought into H. Okay, fine. So what is the final value of SP now? SP plus 2. Because after 2 bytes are accessed, the current value of SP is 27FF. Therefore, after the pop H instruction, the value of SP is same because it is minus 2 and plus 2. Content of HL pair is 1006H. Therefore, he is simply asking what is the value of SP and HL. So very simple, observe the values of SP. SP is unchanged, same value, and so this is same value 27FF and HL pair contains 1006. Therefore, the option would be C. So same question we have discussed in the classroom course also. So I hope that you have solved this question. So option will be C. Yeah. So let us go for the next one. So this is how we have solved the question. Is it clear? Right. So let us go for the next question. Question number 26. So here the total number of, the question is little bit blurred, do not worry. The total number of memory accesses involved when an 8085 microprocessor executes the instruction LDA 2003. So he is asking, there is some instruction called as load accumulator with the memory address, with the content present at memory address 2003. So this instruction is actually a 3 byte instruction. So 3 byte instruction, what is the meaning of instruction? The meaning of instruction is whatever is the memory content at this 2003. So this data is brought into accumulator. This data is brought into accumulator. Is it clear? Whatever is the memory content at this location, that is brought into the accumulator register. So therefore, as instruction is 3 bytes, so if you observe carefully, it is a 3 byte instruction. Let us start from some address. So it will have some opcode here and lower byte and higher byte. Okay. Lower byte and higher byte. Where is the actual data? This is the instruction present in the memory. So where is the actual data? Actual data is present at 2003. Some data is there. Let us say some 8-bit data is present here. So he is asking how many memory access are required. Very simple. First of all, you have to read the instruction. So to read the opcode, it is called as fetch operation because this instruction and data both are present in the same memory only. So fetch, and this one is the memory read operation. It is a 3 byte instruction, memory read operation, and after decoding the instruction, then it understands that I should go to 2003 location and get the data into accumulator. So this final operation is also into accumulator. So whatever is the data at this location. So this is also which operation? Memory read. So how many memory access are required? Fetch, read, and memory read, and hence the option should be D. So D is the correct option. Okay, that is 4 memory accesses. Next question, the content of register B and accumulator A of 8085 microprocessor. So he has given two contents. So register B content is given, one minute, register B content is given and also register A means accumulator, okay, fine, register A content is also given. So what is the content of, read the question carefully, content of register B and A means the first data will be B, second will be A. So A contains 89H and B contains 3CH, okay, fine. So he says that the contents of A and the status of the flag carry and sign flag S after executing sub B. What is sub B? Subtract the content of B register from the accumulator. So you simply subtract the content of B from accumulator. So subtract the content of B from accumulator. See, think logically. You are subtracting a smaller data from the bigger data. Definitely there is no question of any borrow. In subtraction operation, borrow is given by the status of the carry flag. So therefore definitely carry flag would be 0. You are subtracting a smaller data from the bigger data. You just subtract it, how much it is? You cannot subtract 12, C means 12 from 9, take a borrow, how much it is? 16. So 6, it is a hexadecimal value, so you are taking a borrow of 16, 10H means 16. 16 plus 9, 25 minus 12, how much? 13. 13 means D. What is left here? 7. 7 minus 3, 4D. 4D is the value. Let us look at the binary pattern of this. 4D stands for 0, 1, 0, 0, 1, 1, 0, 1. So what is the pattern of flag register with respect to 8085? Sign, 0, auxiliary carry, parity and carry. So sign flag is represented by MSB of the result, that is 0. Result is a non-zero, so 0 flag is 0. Cross, these are all unused, so put zeros for this X cross. Auxiliary carry here. So actually it can be done in two different methods. I am doing in a shortcut method, or you can take the 2's complement of this one, because in the microprocessor, so manual method is A minus B, but the processor does it as A plus of minus B. It will find out what is the negative value of B, so it will take the 2's complement, then it will add it. So instead of doing that, we can also solve like this, both are same. So therefore auxiliary carry, so simple, if you solve this one, after adding you will not get any auxiliary carry, so you can do in that method also. So here I am doing like this, the result lower nibble is less than the accumulator content, so auxiliary will be 0, if it is less than it is 1, it is greater than, so it will be 0. Parity, how many bits are there? 1, 2, 3, 4. 4 is an even value, therefore parity will be 1. And carry flag, there is no borrow, you did not take any borrow, so carry will be 0. So the content of accumulator is 4D and sign flag is 0, carry flag is also 0, but unfortunately the result does not match with the options which were given, so do not worry. So the UPSC may add the marks to all the candidates, or they can take their own decision, okay, but here the result does not match with the options, okay, fine. If you have done it, definitely you may be added with the score, fine. So this is the actual correct answer, 4D and sign flag 0, carry flag will be 0. Next one. So there is a program given here, you have to find out what is the accumulator content after executing of program. Very simple. First one, read the instruction, MVI move immediate A with 05. So accumulator contains 05H. Next one, MVI B comma 05. So B register contains 05. Next one. So there is a loop here, if you observe carefully, this loop is going to execute by the content of register B. So whatever is the content of B, the loop runs for so many number of times. So add B, decrement B, jump if it is not equal to 0 to some label called as PTR. So unless until the B content becomes 0, this loop is going to run, okay. Finally, this instruction runs and stops the program. So let us see what is the resultant of this particular program. So add B, what is the value of add B? Simple, add the content of B to A and result is stored in the accumulator. Add B, what is the value? 5 plus 5, 10 means it is A. Fine. After that, decrement B, 0, 5 minus 1 will be 0, 4. So is 0, 4 0 or non-zero? Non-zero. If it is non-zero, and the 0 flag will be 0 only. So here you are checking in this particular instruction whether the 0 flag is 0 or not in the previous instruction. So in the previous instruction, after decrementing B, it is a non-zero value, therefore 0 flag is 0 only. So you are checking for Z is equal to 0 or not, hence the condition is true, therefore the program control again goes to the same label, add B. It means that in this program we are just going to decrease the value of B one by one and finally add that value to A. So therefore you just go on adding the value to A. So add this 4 to A again, so add B, the content of A was having 0A, so add the value of B again, So this becomes how much? 10 plus 4, that is 14. 14 stands for 0E. Again decrement this. So it is not equal to 0, therefore 0 flag is 0 only, and hence the condition is true. Again it goes here, add B. So again 3 will be added to it. So this is 14 plus 3 17. 17 stands for 11H. Again B gets decremented, it is not equal to 0. Again the condition is true. Again it will be adding the value of B. So B contains 2 now, it will add B. So it is 13H, 17 plus 2 19. Again it is decremented by 1, 0 flag is 0 only, condition is true. Again it will add this 1 also to it. Therefore now it becomes how much? 14H. Fine, are you able to follow? Yes. So after this one, the value of B becomes 0 0. Now the 0 flag is 1, this condition is false. When the condition is false, the program comes out of the loop, and hence the next instruction is add immediate 3. So 14H plus 3 will be how much? Will be 17H. Okay, it will be 17H. Are you able to follow? Yes, it is simply 17H. 17H after the execution of this last instruction. So finally it is halt, stop the program. So what is the content of accumulators? The content of accumulator is simply 17H. Okay, fine. So this is the answer, that is option A. Is it clear? So 10 plus 4 14 plus 3, that is 17, 17 plus 2 is 19, plus 1 is 20, plus 3 is 27 in decimal, but in hexadecimal it is 17. Is it clear? Right. So option A is the correct answer. I hope you might have solved this question, very simple. Right. Question number 78. Which one of the following is a program that takes an object file generated and generates a file in a binary code called as COM or exe file? See, while writing the program, first of all the programmer writes in assembly language. So first of all in the editor window he will write some assembly program. But the program should be dumped into the memory. So this program is given to a software called as assembler. So what this assembler generates? So this assembler generates the program, converts the program into machine code, which is generally called as object file or object code. So what is this object code? If you take some simple instructions, say move some A comma B. So here opcodes are present in some like which type of, these are like something like a codes in the symbols, but it should be converted into codes like hexadecimal codes. So therefore assembler converts this value into the numeric opcodes. Okay, therefore it converts into machine code that is given by the object code. This object code should be dumped into memory, but should be converted into the executable file. So this is given to one more program called as linker. Linker will make it as absolute object file. Finally it is given to the software called as loader. So what is this loader? At the name itself says it does two things. Loader will do two jobs. What are the two jobs? It will convert this object file into a executable code or .com executable code, and finally it dumps the program to the memory. Dumps program to memory. Is it clear? So therefore, so the option is here. What is the software here which converts the as per the given question, which generates executable code or file? That is simply loader. Okay, fine. So answer is option C. Okay. So the loader is a software which will do two jobs. It converts the object file to the executable code and also dumps the program to memory. Fine. That is the correct answer. Next one. Which of the following opcodes is used if the contents of the accumulator are logically ANDed with the 8-bit data and the results are placed in the accumulator? See, in 8085 it is an accumulator based processor. Most of the ALU operations are done only with respect to accumulator. So in the AND operation, the formats of instruction are, you can perform AND operation between accumulator and some register, or you can perform AND operation between the memory content and the accumulator, and also AND operation between the accumulator and the 8-bit data. So in all these instructions the result is stored in the accumulator only. Are you able to follow? So ANAR, everywhere accumulator is there. So accumulator content performed AND with the register content, result is stored in the accumulator. Okay. So same thing you can apply for the memory, you can apply for the data. So what is he asking here in the question? Very simple. He says that for immediate data, AND operation with the 8-bit data and the results are placed in the accumulator. So what is the correct one? ANI, ANI stands for and immediate data with the accumulator. So option is C here. Here also option is C. Is it clear? Fine. So that is the answer. So ANA will be for the register and memory content. It is not for 8-bit data. He has given for 8-bit data, so option should be C. Fine. So that is the correct answer. Next one is 85. So it is actually a statement and statement 1 and 2. Let us see what is the correct answer. So in such type of questions, always you should read first statement and second statement read as because, and you go on reading the second one so that you won't get confused. Look at the first one. Content in the flag register in 8085 microprocessor is read by push PSW followed by pop instruction. And the second statement, look at this one. See what is the meaning of this. In 8085 there is a flag register, right? So this flag register pattern is something like sign 0, auxiliary carry, parity and carry. So these flags will give you the status after some ALU operation, but this data cannot be directly moved into some register. So it is not accessible into some general purpose registers. So therefore what should we do? First of all, you have to push this PSW. PSW stands for status of accumulator register and flag register. It is a 16-bit value, flag register and accumulator value. First of all, you have to push into the stack memory, then you can access into some general purpose registers. So therefore, in 8085, you cannot move the PSW or flags content into some general purpose register. Therefore, we can say that the content of this is done because the content in the flag register in 8085 is not able to read, means it cannot be read and stored to any general purpose. You cannot move like this. For example, say I cannot write like this, move some A comma F, it is not possible. So therefore this should be done. You have to push into stack, then access from the stack into some register pair. So actually pop instruction has a format of pop some RP register pair. You can bring into some registers. So first of all, you have to push into stack and bring from the stack memory. So the answer is option A, because this is the correct explanation for the first statement. So option is A. Thank you so much. I hope that you might have done the paper very well. So may God bless you. Let us hope for a good positive rank. Thank you so much.
Greetings of the day, dear students. I am Iftikhar Ahmed here, and I have Rajkumar sir along with me. And we will discuss questions from analog electronics. We have about 7 questions from analog, and questions were slightly on the tougher side in electronics paper. First question, Rajkumar sir will discuss.
Thank you, sir. Iftikhar sir. Question number 13, it is going to start in analog electronics in ESE. In op-amp, the effect of asymmetrical between the internal circuit driven by the inputs can be reduced by. First point, the word asymmetric means in your op-amp there is a differential amplifier as an input. In differential amplifier, we are going to construct it by 2 transistors. The 2 transistors cannot be identical, everybody knows that, because practically it is not possible to manufacture both the transistors equally. Due to that reasons, offset will be created in the op-amp. If you see here, op-amp, if you take the op-amp symbol like this, minus, plus, this is ground, we are taking the output V naught, having a supply VCC and a supply minus VE. Generally in the labs also, if you do this experiment without giving any input, there will be an output, everybody knows that. This is the only reason due to offset, input offset. This offset is created due to the reason called asymmetrical nature of your transistors. Okay. This offset, if I want to control it in the lab, what we will do is, generally these 2 supply voltages are equal, we will take. If it is 15, we will take minus 15, 10 or minus, symmetrically we are taking. But now, if you keep here a potentiometer at the negative side, in your op-amp IC there are 2 pins, 1 and 5 pins are called offset null points. Okay. First point, pin number 1 is called offset null negative, pin number 5 offset null positive. If you connect these 2 things, 1 and 5, and minus VE, if you adjust that voltage, automatically due to the imbalance of these batteries, automatically this offset at the final output will become 0. So, according to the given question, there are 4 options they have given. The exact, I think, matching with this answer is connecting the slider of the potentiometer to VCC minus will be the good answer for this. So, this will be the correct answer for this. So, option D, you can take it as a good answer for this explanation. Now, remaining 2 more questions will be answered by the Iftikhar sir.
Yeah, thank you, Rajkumar sir.
Yeah.
The next question is based on some common drain amplifier or a source follower. Now, in this question circuit नहीं दिया है, बस आपसे formula पूछ लिया है कि what will be voltage gain formula. This is the problem with ESE paper. They don't provide circuit diagram and they ask you कि what will be voltage gain. Now, to answer this question, from the formula you will get an idea that this amplifier is using some active load. Okay. For this type of question, the circuit will be in this way. पहले मैं आपको circuit दिखा देता हूँ. From the options, I am drawing this circuit. This will be connected to some VDD. Here input will be given and output taken from source terminal. Here M1 will act as a common drain amplifier, input at the gate terminal and output taken from source terminal. And this MOSFET M2, it will be acting as a load. This will be connected to some V bias. That V bias is a biasing voltage. So, this is the circuit of common drain amplifier. This type of circuit should have been given in the question, but without circuit they have asked what will be voltage gain. It is a bit difficult for students to attempt this type of questions. Anyways, I will give you the solution for this. In our AC analysis, first of all, these supply nodes will be grounded. Okay, V bias node also grounded. Now, if you look at M2, for M2 gate is getting shorted to source. Now, we know from active load topic, when gate and source are shorted, that MOSFET can be replaced by an equivalent resistance RDS2. तो यहाँ पर हम M2 को रिप्लेस करेंगे विथ इक्विवेलेंट रेजिस्टेंस RDS2 because gate is getting shorted to source terminal, and this RDS2 will act like a load. It will be between the output terminal and ground. And there is one more thing in the question. If you look at the options, there is one more term appearing GS1, that GS is actually body effect transconductance. So in this question they are considering body effect also. Normally whether gate or ESE we neglect body effect in the AC analysis, लेकिन यहाँ पर हमें body effect को भी consider करना है. So what we have to do is we have to replace M1 with a small signal model. उसको मैं यहाँ पर दिखा देता हूँ. This will be the small signal model for M1. We indicate here a dependent current source GM1 into VGS, and we need to consider body effect also, and that will be done by showing one more current source here which will be equal to GS1 into Vs, and this is the drain terminal, and we can also show here RDS1. This is the small signal model of a MOSFET when we include body effect also. Then I will show other corrections. Input को हमने apply किया है at the gate terminal, तो मैं यहाँ पर input को दिखा देता हूँ. This is the input. Then between source terminal and ground we have to show RDS2. This is RDS2, and in our AC analysis drain terminal it will be grounded, and this is the output voltage V0. Now you can notice here this RDS1 is between source terminal and ground, तो हम RDS1 को directly दिखा सकते हैं in parallel to RDS2 because this is also between source terminal and ground, and RDS1 also between source terminal and ground. तो हम यहाँ से RDS1 को हटा देते हैं और उसी एलिमेंट को हम यहाँ पर दिखा देंगे in parallel to RDS2. Okay, and this body effect current source GS1 into Vs, that Vs is voltage between source terminal and ground, and that will be nothing but V0. तो इसको मैं लिख देता हूँ GS1 into V0, and one more thing, it will be minus also, there is a negative sign also. We can show this current in upward direction, it will be GS into Vs. अगर आप करंट को नीचे की तरफ दिखाएंगे it will be minus GS into Vs. So there is a minus sign also. Now you can apply KCL at this node. Let me use KCL at the source terminal. Across this parallel combination voltage is V0, so this current must be equal to sum of these two currents. Okay, so let me apply KCL. We get GM1 into VGS minus GS1 into V0 is equal to V0 upon RDS1 parallel RDS2. Now this we need to simplify. अब हम इसको थोड़ा सा simplify कर लेते हैं. पहले तो आप VGS की प्लेस में लिख दो VG minus VS. VG यहाँ पर है VI and VS is nothing but V0. तो VGS को हम यहाँ पर पुट करेंगे VI minus V0. So this becomes GM1 into VI minus V0 minus GS1 into V0 is equal to V0 upon, अब ये जो डिनोमिनेटर है इसको हम लिख देंगे 1 upon 1 by RDS1 plus 1 by RDS2. इसको हम ऐसे लिख देंगे 1 upon 1 by RDS1 plus 1 by RDS2, या फिर उसको हम ऐसे भी लिख सकते हैं GDS1 plus GDS2. Okay, parallel combination is actually 1 divided by 1 by RDS1 plus 1 by RDS2. मैंने 1 upon RDS1 को लिख दिया GDS1 कंडक्टेंस की तरह, एंड 1 upon RDS2 को हमने लिखा एज GDS2. अब आप इस एक्सप्रेशन को थोड़ा सा रीअरेंज कर लेना. इफ यू रीअरेंज इट यू विल गेट एक्सप्रेशन फॉर वोल्टेज गेन. दैट सिंप्लीफिकेशन पार्ट आई एम स्किपिंग, इसको आप रीअरेंज करिए. अल्टीमेटली यू विल गेट वोल्टेज गेन GM1 divided by GM1 plus GS1 plus GDS1 plus GDS2. So, this is the voltage gain of common drain amplifier or source follower, and this type of formula you will be seeing here in option C. So, the correct answer in this question will be option C. This was a question on the tougher side because you have to guess first of all circuit and you need to consider body effect also in the analysis. Anyways, answer for this question is option C. Let me move to the next question. Now, the next question is based on voltage divider biasing. Okay, everybody knows voltage divider biasing. This is a standard biasing circuit for BJT where we use resistors R1 R2 which act like a voltage divider. This is the standard circuit for voltage divider biasing, and we know very well in this voltage divider biasing circuit the condition for stable IC, stable collector current, for stable collector current the condition is 1 plus beta into RE should be much greater than RB. Here RB is a parallel combination of R1 R2. RB is a parallel combination of R1 R2, and normally in the design R2 will be much less as compared to R1. Okay, in standard design of voltage divider bias R2 will be much less as compared to R1. So, this combination I can approximate to R2 also. This is approximation because they have told in the question approximate analysis. तो मैंने यहाँ पर approximation किया है, RB को हमने approximate किया with R2. अब much greater का मतलब होता है कि at least 10 times greater. तो condition बन जाएगा 1 plus beta RE should be greater than or equal to 10 times. RB को हम approximate कर लेते हैं with R2 या फिर मैं ऐसे लिख देता हूँ 10 times RB. Much greater का मतलब होता है at least 10 times greater. That is the design rule we follow in analog electronics. अब 1 plus beta को हम approximate कर लेंगे with beta. So condition बन जाएगा beta RE greater than or equal to 10 times RB. फिर RB को हम approximate कर देंगे with R2. So it becomes 10 times R2. So in this way the correct option for this question will be beta RE greater than or equal to 10 times R2. So again the correct answer here is option C. So these were two questions which I did. Next question will be taken by Rajkumar sir.
Yeah. Thank you sir, Iftikhar sir. I think that the two previous questions, one is a design question I think from voltage divider bias, and one more is a somewhat lengthy question where we cannot expect their body effect, all these things. They have gone out of the area actually. Anyway, the next question is statement 1, statement 2, that is 88, I think 88 question. It's a assertion and reasoning question. You can see the statement 1, I will read from the paper here. The differential amplifier is said to operate in common mode configuration when the same voltage is applied to both of the input terminals. It is very easy to understand. When the inputs are given at V minus and V plus, if you give equal inputs, we call it as common input. Okay. If there is a two different inputs, we call it as a differential input. According to this, the statement 1 is true. Perfect. The statement 1 is true. And if you see the second statement, the ability of a differential amplifier to accept a common mode signal is defined as figure of merit. First, a student should know what is figure of merit. In technical words, figure of merit is nothing but your very popular name in op-amps, CMRR, common mode rejection ratio, is also called as figure of merit. CMRR or figure of merit, anything is okay, which tells that how much the common signals are getting rejected. But according to the statement, he has given accept. They should not be accept, we should reject. So this statement became false. So you should not accept, you should reject. So first one is true, second one is false. According to this, the option we can see, C is the, no?
First true, next false. Yeah, option C will be the good answer for it. Option C will be the better answer for this. The next question will be dealt by Iftikhar sir. Yeah.
Yes, Rajkumar sir, thank you.
Yeah.
The next question is about ramp generator using IC 555. Now you must be knowing monostable multivibrator can act as a ramp generator. Using IC 555 we can make monostable multivibrator and astable multivibrator. Monostable multivibrator can act like a ramp generator. I will just show circuit for it. We short here pin number 7 and 6. Okay, at pin number 2 we apply some trigger. 7 and 6 are shorted, and if you use here some constant current source, then this becomes a ramp generator. This type of circuit can act like a ramp generator. We have to use a constant current source. Normally we have a resistor here, उस resistor को हमने replace किया है with a constant current source, and because of that capacitor जब charge करेगा, that current in the capacitor will remain constant. Now when charging current in capacitor is constant, capacitor voltage increases linearly, and in that way voltage across capacitor will look like a ramp signal. Okay, अगर हम output को दिखाते हैं, it will be in this way. मैं voltage across capacitor की बात कर रहा हूँ. आउटपुट तो एक पल्स की तरह आएगा. V0 will be pulse. This is V0. Okay, and if you show here voltage across capacitor, now that will look like a ramp. वो increase करेगा up to 2 VCC by 3. You must be knowing it from the operation of monostable multivibrator. So this will be the voltage across capacitor, and we can say that capacitor voltage is looking like a ramp signal. Okay, and we have to find here the duration of the ramp signal, right? Time period or duration of the ramp signal. हमें इस time period को find करना है T0. Now because current in capacitor is constant, we can use this expression I into delta T is equal to C into delta Vc. Whenever current in a capacitor is constant, we can use this type of equation in the analysis. Okay, now here I will keep I as it is. Delta T की place में आप लिख दो T0 is equal to C into delta Vc. यहाँ पर delta Vc का मतलब होगा कि by how much amount capacitor voltage is changing. Capacitor voltage is increasing by 2 Vcc by 3. So it will be 2 Vcc by 3. Now this is the expression, or this is the approach to find T0. Now the question here is, how do we get this constant current I? To get this constant current I, we normally use one transistor circuit. कुछ इस तरह का circuit हम यहाँ पर use करेंगे. To get constant current, we use this type of circuit. This will be connected to VCC. This resistor is Re, and these resistors you can name them R1, R2. And here is capacitor C. This capacitor is nothing but this capacitor only. इस constant current source की place में हम कुछ इस तरह का circuit use करेंगे. Okay, this will give us a constant current. Now current in this capacitor, it will be nothing but collector current only, and we will do approximation here. This is collector current approximately equal to emitter current. तो जब आप current I को find करेंगे, that current I will be in this way. I is equal to IC, and that is approximately equal to emitter current only, और उसको हम लिखेंगे in this way. This is, let us say, emitter voltage. तो ये हो जाएगा VCC minus emitter voltage divided by RE. VCC minus VE divided by RE. Now emitter voltage की place में हम लिखेंगे VEB plus voltage across R2. अगर आप एमीटर वोल्टेज लिखते हैं विथ रिस्पेक्ट टू ग्राउंड, इट विल बी VEB प्लस वोल्टेज अक्रॉस R2. वोल्टेज अक्रॉस R2 विल बी VCC इंटू R2 अपॉन R1 प्लस R2. तो वो भी मैं यहाँ पर सब्स्टिट्यूट कर देता हूँ. इट विल बी VCC माइनस VE की प्लेस में हम लिख देंगे VEB, ओके, प्लस VCC इंटू R2 अपॉन R1 plus R2, okay, whole divided by RE. Now this expression we need to simplify. अब आप इसको थोड़ा सा simplify कर लेना. Let me just do some simplification here. It will become I is equal to, if you take LCM R1 plus R2 and simplify, it will become VCC into R1 minus VEB into R1 plus R2. I have directly written simplified expression here divided by RE into R1 plus R2. Now this is the constant current provided by this transistor circuit. Now this I you can substitute here, इस I को आप यहाँ पर substitute कर दो and then rearrange, you will get time period T0 is equal to 2 VCC by 3, okay, into C divided by I. उस I की प्लेस में आप ये वाली एक्सप्रेशन पुट कर देना, it will become C into RE into R1 plus R2 whole divided by VCC into R1 minus VEB into R1 plus R2. So this will be the expression for ramp duration. And if you look at the options, this type of expression you will find again I think in option C only. So many questions in analog they have answer as option C here. I think option C matches with this, right? There is a VB here that you can consider as VEB because we are using PNP transistor. So correct answer is option C, okay. Now this question was also on the tougher side because this idea has to come in the mind, okay. In place of constant current source we have a transistor circuit, only then we can get answer for this. So answer for this question is option C. There are two more questions which Rajkumar sir will take up.
Thank you sir, Iftikhar sir. Last two questions are there, we will finish off other two questions. So I think he is asking about the timer questions, only two questions are came. Previous one also sir has explained, this question also coming from timer only. But here he has used the word VCO. VCO. VCO generally we can design by 555 timer also. There is another IC, we can say 566 timer, okay. Any timer we can use, but there is a design formula for this, no derivation for that. I will show you the timer circuit, how to design it, so that I can show you the formula directly, design formula. You have R1 here, which is a pin number 6, it is VCC or V plus, okay. It is shorted with 8, 5th pin is a control voltage VC, 7th pin there is a capacitor here C1, and 1 is a ground, and there are 2 pins here, pin number 4 and 3. This is a specially designed for VCO 566. It's a triangle input and a square input. You can see this is your 566 timer for us. So VCO in this circuit they have given only design formula for this. That formula, if you see here, center frequency is asking F0, it is 2 by R1 C1 into 1 minus VC by V plus. The student has to practice the formula here, no derivation is there, design formula it is. Actual formula is this one, 2 by R1 C1 means R1 is connected to the 6th pin and 7th pin there is a C1 there, R1 C1, and 1 minus VC, VC is a control voltage given to the 5th pin always in VCO, and V plus is nothing but here VCC. This is a design formula. Who has been studied this, they can answer the question. But according to the option, if you see, there is some more simplification is required here to get this type of answer. If you take 2 into LCM, if you take 2 by R1 C1 V plus minus Vc by V plus. So, if you take LCM, I think this option will be matching with your answer. It is 2 times of R1 C1 V plus minus Vc by V plus. Option D will be the correct. Option D is matching with this answer. So, actually this question a student can do if you know the formula only, because there is no meaning of derivation for this question, and we generally not show interest in teaching VCO designs, and VCO we just teach about 555 timer, not 566 timers, because in the syllabus also they are not mentioned about VCO, but in ESE we know that some questions will come out of the area also. So, anyway, this is one question. Coming to the last question in analog, this slightly somewhat a terminology confusion. See clearly, in reduction in noise and nonlinear distortion, additional stages are used to bring the overall gain up to the level. Clearly understand the statement. We know that in negative feedback amplifiers, noise and nonlinearities can be easily reduced by the technique called as negative feedback, that we know that. Suppose my open loop gain is A. If I apply the negative feedback, automatically the gain will reduce by A by 1 plus A beta times. That means the overall gain is very high, we have been reduced it. If you want to get the same gain, that only is telling, to bring the overall gain up to the level without feedback. Without feedback, how much the gain you have if you want to bring to that level. So, it is without feedback is important here, and introduce as much noise back into the system as that reduced by the feedback amplifier. Whenever you want to reduce that noise, okay, you are increasing the gain, means nonlinearity will increase. To reduce that gain, we have to introduce the noise back again, much noise. So, this option is perfect, option A. Some people can have a confusion that with feedback they will write. According to the terminology, it is not with feedback, without feedback, because you have to get to the level of without feedback. So, option A will be the right answer for this. Option A is good.
I think we need to understand question thoroughly. It should be up to the level of, they should have given.
Up to the level of.
I mean, you want gain without feedback and with feedback similar.
There is somewhat confusion here actually. The terminology is not that much clarity here. Anyway, this is option A will be suitable for this. We both have been analyzed this question, and we came to the part to tell the option A is good answer for this. Okay. Finally, if the
questions were on the tougher side from analog. Electrical,
not expected like this
electrical branch analog questions were quite easy, and there were too many.
Nearly
in electronics, electrical
16 questions,
have come from
but ECE actually they have to give more number of questions.
Yeah, it's a
as
core subject.
Core subject it is, and sir and me will teach around 100 hours. Okay. After all, 5-6 questions are coming, means we are also feeling bad for that.
Yeah, 7 questions have come from analog, and some of them are like very tough
standard formulas and derivative background,
and they are asking directly voltage gain.
Yes, sometimes it happens in ESE, we can't do anything for that.
Maybe in some other subjects you might have got easy questions, so it will compensate in that way.
Yeah. Anyway, these are the options you can see, and you can estimate your marks. Thank you very much.
So that's all from our side.
Thank you.
Stay motivated, keep your hard work. Definitely you will achieve success in life.
All the best.
Yes, thank you.
Thank you.
Please wait for the next.
So good evening dear students. So today we are going to discuss the questions that were asked in EMT. So the first question that you can see that vector potential is a vector. See, I am not going to explain everything, I will just give the key. For detailed solution you can go for the ESE website and you can see the complete solution in this. So the first, vector potential is a vector. Now this vector potential can be scalar as well as vector. So they are asking in terms of vector, right. So in terms of vector it is, so the answer for this one is A, correct. So answer for this is your A, right. Fine. So this is the answer for the first question. Second question, if the magnetic vector potential A is this much, what is the total magnetic flux crossing the surface? The surface has been given. Now the detailed solution you can see in the website. I will just give you the key. The answer is 3.75 for this. So this is the answer for question number 2. Coming to question number 3. This is a simple question. You can see that a vector P is given. So which of the following statement is correct? So solenoidal, we know that if del dot P is equal to 0, that means solenoidal, and del cross P, if it is equal to 0, that means irrotational. So you have to check both the thing, del dot P and del cross P. So when you do the question, you will find C to be the correct answer. This is the answer for question number 3. For detailed solution, again I am saying that you can visit the ESE website. There I have completely solved the question, right. Question number 4. The electric field on the surface of a perfect conductor is given. The conductor is immersed in water with epsilon equal to 80 epsilon naught. Surface charge density. The simple formula we know that dN is equal to rho s. Here electric field is given, you need to convert D is equal to epsilon into E. So when you solve it, you will get the answer as D. So answer for question number 4 is D. Next, question number 5. Again the electric field intensity is given by this value is given, the potential difference between this one. Now this is the basic question. Actually the electrostat part is not mentioned in the syllabus, but still they have asked the question. So here if you check that the potential difference between, so Vx minus Vy is equal to minus of E dot dl from y to x. Here electric field is given. Now since they have used the Cartesian coordinate system, dl will be also dx ax plus dy ay dz, okay, they have written in terms of u, so uz, and then you have to integrate from the limit y to x. So when you solve it, you will get the answer as plus 5, right. So this is basic thing, right. So then the detailed solution is given in the website. This question is from the you can see that the similar question has been already asked in GATE exam. Here in the GATE exam they have asked directivity of the antenna in dB. Here they are asking just directivity, right. So f theta is equal to cos 4 theta is given, they are asking what is the directivity. So if you solve it, you will get as B, 18.02. Again I am saying the detailed solution you will see in the website. Question number 6, right. Next is a question number 7. So question number 7 is basically, it is based on the definition, right. So directive gain they are actually asking. So here the most appropriate amongst this is your C, correct. So we know that GD theta comma phi, it is equal to U theta comma phi upon U average, isn't it, right. So this is basically the answer of question number 7. Next, question number 8. So again this is consider parallel plate capacitor and this is uniformly charged. This is a basic thing. They are just asking what is the energy stored in the capacitor, that is equal to Q square upon 2C. We know it very easily, we can answer. So question number 8 answer is C. Coming to question number 9. Now this question is again out of the box. It is not in the syllabus for the engineering service for the ECE student, but they have asked that two dipoles and their dipole moment has been given. They are asking the potential, right. So actually I will just give you a little brief. This is x axis, y axis, and this is z axis. So here is your, let us say this is dipole P1, this is dipole P2. They are asking what is the potential over here, right. So obviously this is for the electrostats point of view, so which is not actually, this is out of box, it is not in the syllabus, but still few questions from electrostat they have asked. So this complete solution I have given, right, you can see it. So I will just give you the answer. So this is minus 20.25 volt is the answer for question number 9. Question number 10. Now this question is given. So if del dot D is equal to epsilon, del dot E and del dot J, sigma epsilon delta dot E, del dot E, then they are asking what is the material. So the answer for this is linear and homogeneous, correct. The explanation again you can see later on. Question number 10. Next, question number 16. Okay. So this is very simple question. They are asking VSWR. So obviously the VSWR, it always lies between 1 to infinity. That we can easily calculate, and we also know it, right? Next, coming to question number 17. Now here Hz is equal to 0. So Hz equal to 0, Ez not equal to 0, that means TM mode, right? So it is nothing but your TM mode. It is very simple. So direct question. So question number 17, answer is C. Question number 18. So question number 18, if you read all the statement, it is very simple type of question. If you read, now at very high frequency, lumped inductance and capacitor can be used as circuit element. No, because this at very high frequency in the transmission line, the capacitance, right? So it will behave as a short circuit, because this is a stray capacitance, because you know that in a transmission line it is how the capacitor is connected. So a stray capacitance you can treat. So at very high frequency it will start as a short circuit. So that means 4 statement cannot be true, and all other statement if you read, it is if you will make it out. So the most appropriate answer will come as 1, 2 and 3. So question number 18. Next, question number 19. Similar type of question we have also done in the classroom, also in the workbook also you can see. Here they have just changed the frequency. In the workbook, the similar type of question, instead of 4.5, I think it was 3 or 5, something like this was the value. So if you calculate it, again the detailed solution you will see in the ESE website. So answer will be C. Next, question number 68. So again, this is the coaxial cable, inner dimension A and B. We know that the characteristic impedance is given as 60 upon root of epsilon r ln B upon A. So when you use this formula, you will get 16 ohm, the nearest approximately you will get 16 ohm as the answer. So answer for question number 68 is your, yeah, D, correct. Fine. So detailed solution you can see later on. Next, question number 69. This question is again from the GATE exam. This question is exactly from the GATE exam. So answer will be 69, answer is B, right? So I have also solved it in the, you can get it. Now question number 70, which of the following does not satisfy wave equation? Here time and space, here you can see that this is y square. Actually this should be cos square y plus 5 to whatever. So the most appropriate answer for this is 70, answer should be D. Next, copper at high frequency, right? So this statement I have written, I have made you write in the classroom also. So it is a complex with an inductive component, right? 71, answer is C, correct. Next, coming to question number 72, the depth of the penetration of the wave in the lossy dielectric increases with, so if you solve it, it is wavelength. 72, answer is wavelength is the most appropriate for lossy, because skin depth is inversely proportional to frequency, and we know that frequency is inversely proportional to lambda, right? So skin depth for a lossy medium. So when I am saying lossy, so generally skin depth is basically when it is for the we will consider, because they have not given the range what is the sigma upon omega epsilon ratio. So if it is lossy means we will consider to be the maximum loss that it can occur. So we can consider approximately to be the good conductor itself, right? So question number 73. Okay, so here you can see that the answer for this is your skin depth. 73, answer is your D. It is very simple question, right? 74, copper behaves as conductor always. Copper behaves as conductor always. So this is the answer for 74. And 75, a transmission line. So obviously this is it is distortionless. So if you solve it, you will get the answer to be 0.002. So this where I have given you just the key. If you want to see the exact solution, what is the basically how it has been solved, you can visit our website, ESE website. There you will see the detailed solution. So this is all about your EMT. So thank you, all the best.
Okay, good evening students. Right, EC measurements, right, question number 139. So, what they are asking, relative static error, I think basic fundamental question. So, generally we know what is error, right, absolute error, generally absolute error is equal to the deviation of measured value from its true value, this is A minus AT. But what is the relative static error? Always the error is expressed, always the absolute error is expressed in terms of true value of the variable. So, percentage relative static error, or simply what they are asking, relative static error, relative static error is equal to A minus AT upon AT, right. This is nothing but what? Absolute error upon true value, absolute error upon true value, hence which is the correct answer? So, option C. Okay. Next. Yeah, in order to eliminate the effect of temperature variations upon length of the spring, usually you might be studied in PMMC or any other instrument, right. So, how the spring is connected, it is like this. Normally in the PMMC you might be studied like this, right. This is terminal 1 and 1 dash, this is top control spring and this is bottom control spring. So, usually the spring is also used as leads of the instrument. Leads means as a current carrying elements, whenever the spring is carrying the current, if you given the supply between here, right, whenever the spring will carry some amount of current, right, due to internal heating problem, whenever spring will carry the current, some I square R losses over a period of time, some heat will be developed, the spring may be going to get expand. So, to reduce the effect of temperature variations upon the length of the spring, two spring coils in opposite direction are used, right. You observe here how it is wound, two springs are connected, two coiled springs are connected in opposite direction, right. So, whenever the spring is elongated, because the two spring coiled in opposite direction, right, so that it will be get tightened, this is the correct option, hence option A. Right. Variation in the ambient humidity causes variation in the resistance of element, that is usually mixture of, what is this? Actually this concept related to hygrometer. Hygrometer, what is this hygrometer? Hygrometer is used to measure humidity, right. Hygrometer is used to measure humidity, right. You may be observing whenever some cricket matches are going on, because of more humidity, right, to absorb that humidity they are going to use some lithium chloride. But what they are asking question here, right, hygroscopic salt, hygrometer is used to measure humidity, but what is the basic function here? Hygroscopic salt, for example, lithium chloride and carbon on an insulating substrate between metal electrodes, between two metal electrodes, it is like metal electrodes, in between here there is a carbon, right, and plus lithium chloride, right. So, hence option A is the correct answer. If you know this concept, you can able to answer, right. Next. One of the advantages of Ariton shunt is that eliminates the possibility of the meter movement being in the circuit. What is Ariton shunt? You may be knowing very well. In a Ariton shunt, this is the meter movement, right. This is the meter movement, meter resistance is Rm, current flowing through meter is Im. In Ariton shunt, there is a resistive divider network is available. There is a resistive divider network is available. Just you are taking the tappings only here. Resistive divider network is available. You are taking only tappings here. Just simply you are taking the tappings. So 1, 2, 3 like that. Right. So what is the what it will do? What is the right help of, or what is the useful of return shunt? The main advantage is, right, so that eliminates the possibility of the meter movement being in the circuit with limited shunt resistance, no, right, without any series resistance, right, without any shunt resistance. You look at, there is a simple residue divider network is available. So without any shunt resistance is the correct statement. This is one of the advantage. With minimum series resistance, it may not be correct. Hence option C is the correct answer. Okay. Right. Next. A rosette gauge. In a rosette gauge, the angle between any two longitudinal gauge axis, so is usually 45 degrees. Different types of rosette gauges are available, right? It is like this, suppose, right. One of the rosette gauge is the rosette gauges, right, the angle between them 45 degrees, right, 45 degrees, 60, 90, different types of rosette gauges are available, right, but what they are asking, longitudinal gauge axis, the angle between any two longitudinal gauge axis, so hence is a 45 degrees. Okay, fine. Next, the inductance of a 25 ampere electrodynamometer. So what is the question given? The question given is EDM type instrument, electrodynamometer type instrument. Okay. Right. What is the current given? The given current is 25 amperes. Right. Given current is 25 amperes. Fine. Given current is 25 amperes. Okay. dm by d theta. dm by d theta is given. Right, electrodynamometer ammeter changes uniformly at the rate of 0.0035 microhenry. This is not milli, this is a microhenry. Please take care, because it is a direct question only. It is our workbook question only. 0.0035 microhenry. Then Henry per radian. Fine. So spring constant also given. What is the spring constant? Tell me. 10 to the power of minus 6 Newton meter per radian. What they are asking, deflection theta. Deflection theta is equal to I square by Kc, right? I square by Kc into dm by d theta. Yeah, directly you can substitute, you will get the answer. 25 amperes, Kc value 10 to the power of minus 6 Newton meter per radian, right, 0.0035 10 to the power of minus 6 Henry per radian. This radian cancel, 10 to the power of minus 6 cancel. But whenever radian cancel, you will get value. What is the value? How much? 625 into 0.0035, 2.18 radians. This is converted into degrees. 2.18 into 1 radian is equal to 180 degrees by pi. So your final answer 125 degrees. This is the final answer. Hence option D is the correct answer. Okay. Right. Fine. All the best. The next subject will continue. Okay. Over.
So let us solve questions of signal system. Myself, Rohit Tripathi, and along with me, Naveen sir is also here, so he will explain also some questions. तो सबसे पहले क्वेश्चन नंबर 29, इसमें अगर आप डाटा देखें तो क्या है, लेट एक्स से टी बी एन एनालॉग सिग्नल, ठीक है, विथ बैंडविड्थ 6 किलोहर्ट्ज. We wish to use n equal to 2 की power m point DFT to compute the spectrum of the signal with resolution. यहाँ किसकी बात हो रही है, resolution की, less than or equal to 200 Hz. Now what is the minimum length of the analog signal recorded? ठीक है. So in case of DFT, the resolution is given by formula, and the formula is 2 pi by n. So this is the formula for resolution. ठीक है, ठीक है, this is the formula for resolution 2 pi by n. And what is the unit? Unit is radian per sample. ठीक है. अच्छा, अब हमें इसे कन्वर्ट करना है रेडियन पर सेकेंड में. So we are going to convert this resolution in the unit रेडियन पर सेकेंड. तो इसके लिए क्या करना है, इसे आप डिवाइड करो टीएस से. इसे किससे डिवाइड कर दो, टीएस से. ओके, ठीक है. तो अभी यूनिट क्या होगा, रेडियन पर सेकेंड. ओके, अब इस रेजोल्यूशन को कन्वर्ट करना है हर्ट्ज में, क्योंकि यहाँ पर रेजोल्यूशन लेस देन और इक्वल टू 200 हर्ट्ज है, तो यूनिट मैच करना होगा. तो अब यूनिट मैच करने के लिए यहाँ जो भी रेजोल्यूशन रेडियन पर सेकेंड में आया, इसे हर्ट्ज में कन्वर्ट करना है. तो हर्ट्ज में कन्वर्ट करने के लिए कितने से डिवाइड करोगे, 2 पाई से. सो 1/2 पाई, 2 पाई से डिवाइड कर रहा हूँ, इनटू दिस. ओके, अभी यूनिट क्या आएगा, हर्ट्ज. तो इससे आप क्या लिखते हैं, 1/n/ts. ठीक है. अच्छा, अब अगर मैं क्वेश्चन के अकॉर्डिंग चलूँ, सो व्हाट इज गिवन दैट the resolution, what is resolution is how much, 1/n/ts should be less than or equal to 200 Hz. ठीक है. तो 1/n/ts इसका यूनिट भी किस में है, हर्ट्ज में, और क्वेश्चन में लिखा गया रेजोल्यूशन शुड बी लेस देन और इक्वल टू 200 हर्ट्ज. अच्छा, अब इसके बाद यहाँ से आप NTS क्या लिखते हैं, सो NTS शुड बी ग्रेटर देन और इक्वल टू 1/200. तो इसे आप लिखते NTS शुड बी ग्रेटर देन और इक्वल टू 0.005 सेकेंड. एंड व्हाट इज NTS, हियर n इज नंबर ऑफ सैम्पल्स इन DFT. ओके, और n पॉइंट DFT में जो n है उसकी बात हो रही है, इंटू TS. सो n इंटू TS विल बी टोटल टाइम इंटरवल. तो यहाँ पर यही पूछा गया था इस क्वेश्चन में कि द मिनिमम लेंथ ऑफ द एनालॉग सिग्नल रिकॉर्डेड. So this is the minimum, this is the length of analog signal recorded, and for minimum length we have to select this equality. So ये जो NTS है ये लेंथ है और इसकी वैल्यू मिनिमम लिखनी है, तो आंसर कितना होगा, 0.005 सेकेंड. तो अगर आप देखें तो कौन सा ऑप्शन मैच होगा, ऑप्शन सी. ठीक है. अब नेक्स्ट क्वेश्चन की ओर चलते हैं. सो क्वेश्चन नंबर 30, इस क्वेश्चन को थोड़ा केयरफुली देखना है. सबसे पहले द Z ट्रांसफॉर्म ऑफ द कॉजल ऑफ द इम्पल्स रिस्पॉन्स ऑफ ए कॉजल LTI सिस्टम इज. सो दिस इज ट्रांसफर फंक्शन. तो h ऑफ z गिवन है और h ऑफ z कितना है, 1/2. सो z इनवर्स अपॉन 2 इन ब्रैकेट z की पावर -2 -4.5 z इनवर्स प्लस 5, ये h ऑफ z है. एंड सिंस इट इज़ द कॉजल, इट मीन्स इसका जो भी इनवर्स h ऑफ n होगा वो किस टाइप का सिग्नल होगा, राइट साइडेड सिग्नल होगा. राइट साइडेड सिग्नल. वाई, बिकॉज सिस्टम इज कॉजल एंड दैट इज़ वाई HN विल बी अ राइट साइडेड सिग्नल. अच्छा, अब इसके बाद सिस्टम आउटपुट गिवन है y ऑफ n. ठीक है. y ऑफ n क्या है, y ऑफ n इज इक्वल टू u ऑफ -n प्लस 0.5 की पावर n un. अब अगर आप इसे ध्यान से देखो तो इसमें फर्स्ट टर्म है left sided signal. Okay, what about second term? Second term is right sided signal. ठीक है, राइट साइडेड सिग्नल. ओके, तो y ऑफ n किस टाइप का सिग्नल है? बोथ साइडेड सिग्नल है. तो y ऑफ n किस टाइप का सिग्नल है? बोथ साइडेड सिग्नल है. ओके, अच्छा, अगर आपको y ऑफ n कैलकुलेट करना है, ठीक है, तो एलटीआर सिस्टम का आउटपुट कैलकुलेट करना है. कैसे कैलकुलेट करते हो? x ऑफ n कन्वोल्यूशन विथ hn से. So by applying Z transform, YZ will be equal to XZ into H of Z. इसमें थोड़ा आगे बढ़ते हैं. तो X of Z में क्या लिखता? X of Z will be equal to YZ upon H of Z. ठीक है. अच्छा, Y of n अभी हमने लिखा है. इस Y of n से अगर आप YZ लिखें तो YZ आप क्या लिखते? देखो un का z ट्रांसफॉर्म होता है 1/1 माइनस z इनवर्स. अब अगर n को माइनस n से रिप्लेस करोगे तो ट्रांसफॉर्म में z को किससे रिप्लेस करो? z इनवर्स से. तो 1/1 माइनस z इनवर्स में z को z इनवर्स से रिप्लेस करो तो क्या लिखते? 1/1 माइनस z. और जो सेकंड टर्म है इसका z ट्रांसफॉर्म z अपॉन z माइनस 0.5. अभी हमने yz लिख लिया. ठीक है, चलो इधर लिखना yz. तो yz को थोड़ा सिंप्लीफाई कर रहा हूँ. क्या लिखता है? z माइनस 0.5 प्लस z से इसको मल्टीप्लाई करो तो आप लिखते z माइनस z स्क्वायर, ओके, अपॉन 1 माइनस z इंटू z माइनस 0.5. ठीक है, अपॉन h ऑफ z. h ऑफ z यहाँ हमने लिखा है तो 1/h ऑफ z लिखना है क्योंकि इधर h ऑफ z डिनोमिनेटर में है. तो 1/h ऑफ z अगर आप लिखो तो आप क्या लिखते? अब न्यूमरेटर में क्या लिखूंगा? 2. फिर न्यूमरेटर में यहाँ से क्या लिखता? ये वाला टर्म. तो z की पावर -2 माइनस 4.5 z इनवर्स प्लस 5 अपॉन ये z इनवर्स वाला टर्म. ठीक है. अच्छा, अब इसको सिंप्लीफाई करना है. अब देखो इसमें 3-4 स्टेप्स लगेंगे तो वो स्टेप्स आप यूज़ करिए. ठीक है, तो 1-2 स्टेप्स मैंने सॉल्व करके रखा है क्योंकि ये लेंदी क्वेश्चन है तो मैंने इसको सॉल्व करके रखा है और मैं रिज़ल्ट इसको लिखता हूँ कुछ इस फॉर्म में. इसको जब आप सिंप्लीफाई करेंगे तो आप क्या लिखते? z प्लस z 2z माइनस 0.5. ठीक है, फिर 2z माइनस 0.5 एंड माइनस z स्क्वायर. ठीक है, अपॉन 1 माइनस z इंटू z माइनस 0.5. अच्छा, ये वाला जो टर्म है इसमें आप z स्क्वायर से न्यूमरेटर और डिनोमिनेटर को मल्टीप्लाई कर दो. ठीक है, तो z इनवर्स और z स्क्वायर को मल्टीप्लाई करो तो डिनोमिनेटर में क्या लिखोगे? z. अब 2 से इन सब को मल्टीप्लाई करो, थोड़ा सिंप्लीफाई करो. तो सिंप्लीफाई करके जो फैक्टर आएगा वो मैं डायरेक्ट लिख रहा हूँ. 2 इंटू z माइनस 0.5 इंटू 5z माइनस 2 इस फॉर्म में आएगा. अब अगर ध्यान से देखो तो इसमें 2 टर्म्स कैंसिल आउट हो रहे हैं, z माइनस 0.5 एंड z माइनस 0.5. ठीक है, अब आप फर्दर इसको सिंप्लीफाई करेंगे तो जो रिज़ल्ट है वो कुछ ऐसा आएगा. वो रिज़ल्ट कुछ ऐसा आएगा. जो लास्ट एक्सप्रेशन है मैं डायरेक्टली वो लास्ट एक्सप्रेशन लिख देता हूँ. 1 मिनट थोड़ा वेट करना. ठीक है. तो लास्ट एक्सप्रेशन कुछ ऐसा है. इसको आप लिखते तो क्या लिखते? ठीक है, इसे मल्टीप्लाई करो तो आप लिखते 2z माइनस 0.5 माइनस z स्क्वायर. ठीक है, 2 से इन दोनों को मल्टीप्लाई करो. 2 से 5z कितना हुआ? 10z माइनस 2 इंटू 2 कितना? 4. ओके, अपॉन डिनोमिनेटर में क्या? 1 माइनस z, यहाँ पर क्या? z. अब z से न्यूमरेटर को फर्दर डिवाइड कर दो तो z से इस वाले टर्म को मैं डिवाइड कर दूंगा, इसको एज इट इज़ रहने दूंगा. 2z माइनस 0.5 माइनस z स्क्वायर इंटू 10. z से डिवाइड करो तो 10 माइनस 4 z इनवर्स अपॉन 1 माइनस z। यहाँ तक तो हम लोग पहुँच गए। अब एक चीज़ ध्यान से देखना, अच्छा ये जो हमने लिखा है ये क्या रिप्रेजेंट कर रहा है, x ऑफ z। अब अगर आप देखो तो यहाँ पोल लोकेशन किधर मिला, तो x ऑफ z का पोल ऑफ x ऑफ z ये किधर लाई कर रहा है, z इक्वल टू 1 पर। अब अगर z इक्वल टू 1 पर है तो ROC की दो पॉसिबिलिटी, ROC शुड बी आइदर मॉड z लेस देन 1 और मॉड z ग्रेटर देन 1, ठीक है। अच्छा अगर ROC मॉड z ग्रेटर देन 1 होगा तो x ऑफ n राइट साइडेड हो जाएगा, h ऑफ n इज ऑलरेडी राइट साइडेड, सो राइट साइडेड कन्वोल्यूशन विथ राइट साइडेड yn विल बी ऑल्सो राइट साइडेड। बट अगर आप ऑप्शंस में क्वेश्चन में देखो तो यहाँ पर yn बोथ साइडेड सिग्नल है, इसका मतलब xn राइट साइड सिग्नल नहीं होगा। अब अगर x ऑफ n राइट साइडेड सिग्नल नहीं है तो x ऑफ n कैसा है, लेफ्ट साइडेड सिग्नल है। तो यहाँ से अगर आप ROC लिखते किसके लिए, x ऑफ z या फिर x ऑफ n के लिए, तो आप लिखते मॉड z लेस देन 1। इट मीन्स इनवर्स ऑफ x ऑफ z, इट मीन्स x ऑफ n विल बी अ लेफ्ट साइडेड सिग्नल। तो x ऑफ n किस टाइप का सिग्नल होगा, लेफ्ट साइडेड सिग्नल होगा, ठीक है। अब अभी हम लोग और डिटेल में नहीं जा रहे हैं, हम लोग बस के लिए इतना देख रहे हैं। यहाँ 4 ऑप्शंस हैं, थोड़ा ध्यान से अगर हम लोग ऑप्शंस को देखें तो फर्स्ट ऑप्शन राइट साइडेड है क्योंकि यहाँ un मल्टीप्लाइड है। ऑप्शन सी राइट साइडेड है क्योंकि इधर un मल्टीप्लाइड है। ऑप्शन बी में अगर देखो तो ये वाला टर्म राइट साइडेड है, ये वाला टर्म राइट साइडेड एंड दिस टर्म इज लेफ्ट साइडेड, ठीक है, दिस टर्म इज लेफ्ट साइडेड। तो x ऑफ n इधर कैसा है, बोथ साइडेड सिग्नल है, जबकि हमने देखा x ऑफ n कैसा होना चाहिए, लेफ्ट साइडेड होना चाहिए, बट यहाँ x ऑफ n कैसा है, बोथ साइडेड है। तो b भी नहीं है और इस तरह d भी नहीं है क्योंकि d में ये वाला टर्म कैसा है, ये वाला टर्म है राइट साइडेड सिग्नल, ठीक है। फिर ये लेफ्ट साइडेड है, ये राइट साइड है, ये राइट साइड है, तो 3 टर्म्स राइट साइड हैं, एक टर्म लेफ्ट साइड है, कॉम्बिनेशन बोथ साइडेड बनेगा। तो x ऑफ n यहाँ पर कैसा आया, बोथ साइडेड सिग्नल आया, जबकि हमने सॉल्व किया है, डिटेल में सॉल्व किया है, बड़े अच्छे से सॉल्व किया है। x ऑफ n कैसा मिलना चाहिए, लेफ्ट साइड सिग्नल मिलना चाहिए, बट इधर x ऑफ n इधर भी कैसा मिला, बोथ साइड मिला, मतलब ये 4 के 4 ऑप्शंस रॉन्ग हैं, ठीक है। अब अगर 4 के 4 ऑप्शंस रॉन्ग हैं इसका मतलब ऑल ऑप्शंस आर रॉन्ग, यहाँ पर कोई ऑप्शन मैच नहीं होने वाला है। आप इसको अगर x ऑफ z को आप ये मल्टीप्लाई करके जब आप इन्वर्स लिखेंगे ना तो सारे जितने भी इन्वर्स आएंगे वो लेफ्ट साइडेड ही आएंगे, तो कोई भी ऑप्शन मैच नहीं होगा, ठीक है। तो ऑल ऑप्शंस आर रॉन्ग, ऐसे केसेस में मार्क्स टू ऑल होता है इस टाइप के क्वेश्चंस में जब सारे ऑप्शंस रॉन्ग होते हैं, ठीक है। इसके बाद अब नेक्स्ट क्वेश्चन पर चले, ठीक है। सो व्हाट इज नेक्स्ट क्वेश्चन, so next 2-3 questions will be solved by Naveen sir, okay.
Thank you Rohit sir, thank you so much. So we can solve the question number 97. So Laplace transform for the periodic waveform shown in the figure where a is equal to 1, 2a is 2 and 3a is 3 and 4a value is equal to 4. So it is a causal signal. So we already studied about the Laplace transform for causal signal. So it is t and this value is equal to f of t. If we draw the sketch, it looks like this, it is 0, 1, 2, 3 and it is equal to 4. The amplitude value is equal to 1 and this value is equal to -1 is present. This is a given signal. So we can write about the value here called as f1 of t. So that f1 of t will looks like this. So shown here like f1 of t for one period and that period value capital T is equal to 2 we are having. So 0, 1 and 2, it is 1 and this value is -1. So if you write f1 of t is written as like this, it is u of t. So minus 2 into u of t minus 1. Similarly, plus u of t minus 2 is a value. So, apply Laplace transform. We are applying the Laplace transform. So, f1 of t will convert into f1 of s. f1 of s is equal to 1 by s minus 2 into e to the power of minus s upon s plus e to the power of minus 2s upon s is present. That is f1 of s. So, it is a switching periodic signal or causal periodic signal. We can write the Laplace transform. F of s is equal to f1 of s 1 minus e to the power of minus st. It is a direct formula already studied in the classroom. And the t value is equal to 2, substitute this and f1 of s also calculated. So, what we are trying to doing here is we are just substituting all those values in the equation. So, f of s, where f of s value is equal to f1 of s, that is 1 by s into 1 minus 2 e to the power of minus s plus e to the power of minus s whole square. I am writing e power minus 2s as like this. So, whole divided by the value is equal to 1 minus e to the power of minus 2s. So, here also by expansion 1 by s. So, this looks like 1 minus e to the power of minus s whole square, and this looks like a square minus b square, written as a minus b, 1 minus e power minus s and a plus b e to the power of minus s. So, this square and this term will get cancelled out, and further simplification. So, 1 by s value is equal to that of e to the power of minus s by 2 is taken common. So, value is equal to e to the power of s by 2 minus e to the power of minus s by 2. So, whole divided by e to the power of minus s by 2 is taken common. So, e to the power of minus s by 2 e to the power of plus s by 2 minus e to the power of minus s by 2 is present. So, these two will get cancelled out and we can get the tan inverse. So, tan of h. So, writing directly that one. So, that is equal to 1 by s tan h hyperbolic of s by 2, and the option is so 1 by s tan h s by 2, option A is the correct answer. So, option A is the correct answer. So, coming to the next question. So, question number 143, match the following list. He was given square waveform. So, square waveform is the waveform having a made up of fundamental frequency plus an infinite number of odd harmonics will be exist, which already studied in the Fourier series. And coming to the triangular wave, which consists of less harmonics. So, triangular wave will contain less harmonics, square wave will made up of fundamental frequency plus an infinite number of odd harmonics. And we can tell about two waveforms which deliver same power to identical resistors, means those RMS voltages will remains the same. These two waveforms which deliver identical power, the RMS voltage remains the same. Then what happened is the P is equal to 2. So, P is 2 out of these two, and Q is equal to 1, Q is 1 and R is 3. So, option A is the correct answer. So, as from the Fourier series we got this relation. So, next question. Question number 147, in the design of digital IR filters by means of binary transformation, the design specifications are given, match the following list. So, N and delta F is given, we know capital N is the order, which is called as the order, and delta F is called as the bandwidth, which is given as a bandwidth. So, N and delta F is fixed, talking about the filter specifications. What happened to the each filter specifications he was asking. So, when we see about this one, so P, that means when N and delta F are fixed, the design is become complicated such that the design is completely determined for the Butterworth filter case by obtaining the value of the attenuation at FA directly. This one in the Butterworth filter designing. So, when N and delta F is fixed, the designing of is completely determined for the Butterworth filter case by obtaining the value of attenuation by FA directly. And now delta F and delta is fixed. If these two are fixed in the designing of filter, then definitely the design procedure has to start with the evaluation of the order of the filter necessary to meet the specifications in terms of the desired attenuation, transmission bandwidth and passband deviation. This delta is called as the passband deviation, which is called as the passband deviation we are having. So, next one is when n and delta is fixed, so the leftover is the filter is completely specified and the transition bandwidth is directly obtainable during the design procedure. So, this is the option D, which is the given statements directly with different cases, what happened n, what happened delta f, that is bandwidth, and what happened to small delta. Okay. So, these are the questions asked in signals and system. So, next subject will come. Thank you.
This year 6 questions have been asked from this basic electrical engineering. One question is from transformer and other question from the DC machines, one more question from the induction machines and one more question from the power plant and the last question from the batteries. Except the synchronous machines, from the remaining all the units, from each unit one question was given. Now first come to the transformer. Now correspond to transformer, in this example in the data itself turns ratio is given. In the question he gave one statement, secondary to primary, that means N2 by N1 ratio is given. What is the N2 by N1 ratio? Equal 0.1. And correspond given information, secondary voltage is given. What is secondary voltage? How much here? 100. Secondary voltage is 100. Now correspond transformer, always voltage ratio. Correspond to transformer, always the voltage ratio directly proportional turns ratio. With the transformer, always voltage ratio directly proportional turns ratio. In the question itself, secondary voltage is given. What is secondary voltage? How much? 100. 0.1. If you simplify this one, then whatever the V1 is equal to 1000 volts. If you simplify this one, what is V1 equal to 1000 volts. Come to second one. Now for this particular example, in the question he gives statement as shunt machine. He gave the data as a shunt machine. In the data itself, voltage is given and armature resistance also given. Now what he asked you to find out? He asked you to find out the induced EMF. In the question he gave one statement. Now one is working as a generator, other one is working as a motor. Working as a motor. Now first let us see the calculations correspond generator. Calculation correspond generator. Now correspond generator, if you develop the block diagram. Now for this example here, what is the voltage given as a 230 volts? What is the voltage given as a 230 volts? In the data itself given, what about the shunt field resistance of this one is a 115 ohms and armature resistance. What about this armature resistance is equal to 0.5 and correspond given information, what about the respect to load current? But the current of this one is how much here? 50 amperes. Now let us find out the respective generated voltage. Let us find generated voltage. Now for this one, first let us find out the field current. IF equal to, we can write as V by shunt field resistance. In the parallel circuit, voltage across all the branches are same. The same 230 volts, same 230 volts is coming across this one. We can write this as a 230 by 115. If you simplify this one, what is the current of this one equal to 2 amperes. Now from this one, can you find out respective armature current? Can you find respective armature current? If you apply KCL at this point, if you apply KCL at this point, we can write this as a, this armature current equal to IL plus IF. Now 50 armature current equal to 50 amperes. Armature current equal to 52 amperes. Now finally, what is the requirement is the induced EMF. Induced EMF, we can write this with a V plus IARA. In the data itself given, what is the voltage of this one? 230. Armature current 52. What is the armature resistance is the 0.5. In the question itself they mentioned armature resistance 0.5. Now by simplifying this one, can you find respect to EZ value? If you simplify this one, what about the EZ equal to 256. Now this is the induced voltage. This is the induced voltage correspond to which one here? When the machine behaving as a generator. When the machine behaving as a generator. Now देखिए from the options, without going for the motor, directly you can select the answer. देखो the 256, we can eliminate these three options. Which one is supporting here? A. The same analysis we can repeat for motor also. होना बोले तो. Now correspond to motor. Same analysis we can repeat for the motor also. From the given information, now for the motor electrical input, what the given line current of this one is 50 amperes. Again for the field current we can repeat the similar calculations. For the field current we can repeat the similar calculations. Again correspond this example also, the field current equal to, we can repeat the same steps. But in this example, to find out the armature current, in this example to find out armature current, what about armature current equal to 48 amperes. Now finally what is our requirement is the induced voltage. What is the requirement is the induced voltage? Back EMF. Now correspond to DC motor, what is the induced voltage is the back EMF. If you substitute the respective values, by simplifying this one we get the induced voltage correspond to motor, Come to the next question. Now in this particular example, what is this question is correspond which one here? Induction motor. This question corresponds to induction motor. In the data itself given number of poles equal 4, and what is the supply frequency is 50 Hz. First can you find out respect to synchronous speed? Synchronous speed is the 120 F by P. In the question itself supply frequency is given, but given supply frequency is 50 Hz. But the number of poles are the 4. What about this NS equal to 1500 RPM. In the given example, what is asking the one of the requirement for this one slip. क्या चाहिए जी आपको? One of the requirement for this one slip. Now to find out slip, simply can you write this here NS minus CN. In the data itself rotor speed is given, but the given rotor speed is how much? Now 1455. Now by simplifying this one, can you find the slip value? Check it out. Now for this one, slip is approximately 0.03. Come to the next one. But the one more requirement for this one is asking the rotor induced voltage. What is asking rotor induced voltage? But you have to read the question very carefully. Is asking rotor induced EMF at what instant? Standstill. This is a very important word. Is asking at standstill condition. Now what is our general formula for the rotor frequency equal to? What do you write this as SF? But in the question what they mentioned is asking at standstill condition. Standstill condition means what is the rotor speed equal to 0. Standstill condition means what is rotor speed equal to 0. When the rotor speed is equal to 0 at standstill condition, then what is slip equal to 1, slip equal to 1. When not a slip equal to 1, then what about rotor frequency? F dash is rotor frequency, then here slip is a 1, what is the frequency of this one? 50. That means here correspond given options, which one supporting here?
And this question is related to the reactor, right? So PWR and BWR, pressurized water reactor and boiling water reactor. In pressurized water reactor, basically we have to maintain high pressure, right? And that is why it is utilized. So simple question, database question, correct? Information based question was there. So high pressure maintain करना होता है. That is why here two loops are there, correct? तो इसलिए इसका आंसर क्या हो जाएगा? High pressure. Now come to the next question, that is question number 111. In this question, that battery discharging and charging question is there, which is connected with the ampere hour efficiency. So what is ampere hour efficiency? Ampere hour efficiency basically is equal to the ampere hour discharged, correct? Ampere hour discharged and ampere hour charge, correct? यानी ऐसे simple language में समझिए, while charging how much ampere hour it is taking, and while discharging how much ampere hour it is delivering. Very simple, right? So this efficiency is given, how much it is? 0.85 is equal to ampere hour discharge. So that ampere hour discharge is 7 into I discharge, because we don't know what is the discharging current, divided by what is the ampere hour charging. It is given, right? So it is given as 6 into 3. So what is I discharge from here? I discharge is equal to, just by calculation, 2.1857 ampere, right? So this is the current. Now voltage it is given, that terminal voltage is maintained, that is 12 volt. So what is resistance? Voltage divided by current, right? So how much it is? 5.49 ohm. That is the answer, right? I think B answer is there, right? So this is our answer. Very simple, correct? Now come to the coil consists of, yeah, this is the question related to some fundamental concept. In a coil, basically what we know, what is L? First of all, what is the basic definition of L? That in that question they are asking. So वो basic definition क्या होता है? N d phi by di, right? ये basic definition है, correct? N d phi by di. So how many turns are there? 750 into that d phi 1200 into 10 to the power minus 6 upon that change in current is what we can write 10. So how much it is? 0.09 Henry. Now they are asking E also. So what is EMF? EMF, either we can use L di by dt or N d phi by dt, right? So any one we can use, right? So what is L di by dt? So EMF is equal to, that L is 0.09 into di by dt. How much current? 10, in which in 0.01 second. Or we can write, what is N d phi by dt? N is given 750 into d phi by dt, that the flux is 1200 into 10 to the power minus 6 upon 0.01. So in both the cases we will have answer 90 volt. 90 volts. So our answer will be B in 0.09, and this is 90. So thank you so much, all the very best.